Which of the following accurately describes the purpose of sklearn's bunch object? A. It is a custom container specifically designed to hold data and labels used in machine learning models. B. It is a generic data structure for storing arbitrary Python objects. C. It acts as a wrapper for NumPy arrays, offering convenient access to data and its metadata. D. All of the above. This is correct. Sklearn's bunch object is designed to store data and labels in a structured way, making it ideal for working with machine learning datasets. It provides attributes like data features and target labels, streamlining data organization. True. This is also correct. Bunch objects can hold various Python objects beyond data and labels, making them versatile data containers. True. This statement is true. Sklearn's bunch object frequently stores data as NumPy arrays, offering efficient data handling and operations. True. Since A, B, and C are all accurate, D is the correct choice. Sklearn's bunch object combines the features described in these options, making it a comprehensive and convenient tool for machine learning tasks. True. D. 1. LTBGT dataset loading and preprocessing. LTBGT bunch objects are frequently used for loading and storing datasets. They can hold features X and corresponding labels Y in a structured manner, simplifying the process of preparing data for machine learning tasks. This approach promotes modularity in your code and avoids repeating loading procedures. In real-world scenarios, data often comes in different formats. Bunch objects help you unify this data into a consistent structure. For example, consider loading a CSV dataset with features like age, income, and occupation, and a corresponding label for customer churn. You can use a bunch object to store this data in a way that is easily accessible for training your churn prediction model. Python. Import pandas as PD. From sklearn, datasets import load iris. Load iris dataset into a bunch object. Iris load iris. Access features and labels. X iris. Data. Y iris. Target. Create a pandas data frame for better visualization. Data frame PD. Data frame data X. Column series. Feature names. Data frame target Y. Print data frame. Head. Data structures. Data preprocessing. 2. LTBGT model training and evaluation. LTBGT bunch objects provide a convenient way to package data for model training. You can pass a bunch object directly to a sklearn model 39's fit method, reducing the need for separate variables for features and targets. This promotes code readability and simplifies training pipelines. After preprocessing your data, you'll use it to train a machine learning model. Bunch objects streamline this process. Instead of managing separate variables for features and labels, you pass the entire bunch object to your model's training function, improving code clarity and efficiency. Python. From sklearn, linear model import logistic regression. From sklearn, model selection import train test split. From sklearn, datasets import load iris. Load iris dataset into a bunch object. Iris load iris. Split the data into training and testing sets. Xtrain. Xtest. Ytrain. Ytest train test splitters. Data. Iris. Target. Test size 0.2. Random state 42. Create a logistic regression model. Model logistic regression. Train the model directly on the bunch object. Model. Fit Xtrain. Ytrain. Make predictions. Predictions model. Predict Xtest. Evaluate the model's performance. Machine learning models. Model training and evaluation. LT font style font size 14px GT LTBGT data structures LTBGT LT font EGT. Bunch objects exemplify a custom data structure tailored for machine learning applications. Understanding data structures is fundamental in programming, as they govern how you store and organize information. Python. Dictionaries as data structures. Data name 1C, age 25. Print data name output 1C. LT font style font size 14px GT LTBGT object-oriented programming OOP LTBGT LT font EGT. Sklearn's bunch object is an example of an object in OOP. It encapsulates data and methods, attributes and functions to manage and operate on that data. Python. Class person. Def in itself. Name. Age. Self. Name. Self.age age. Def greet self. Print f hello. My name is self.name. Person 1C. 25. Person. Greet output hello. My name is 1C. LT font style font size 14px GT LTBGT NUMPY arrays LTBGT LT font EGT. NumPy arrays are a foundational data structure in Python for numerical computations. Sklearn often uses NumPy arrays to store and process data efficiently. Python. Import NumPy as NP. Create a NumPy array. Array NP. Array 1, 2, 3, 4, 5. Perform operations on the array. Print array 2 output 2, 4, 6, 8, 1 0. LT font style font size 14px GT LTBGT data preprocessing LTBGT LT font EGT. Data preprocessing is crucial for preparing raw data for machine learning. This involves tasks like cleaning, transforming, and scaling data to ensure it's in a suitable format for your model. Python. From sklearn, preprocessing import standard scalar. Create a standard scalar object. Scalar standard scalar. Fit the scalar to your data. Scalar. Fit xtrain. Transform your training and testing data. Xtrain scaled scalar. Transform xtrain. Xtest scaled scalar. Transform xtest. LT font style font size 14px GT LTBGT machine learning model SLTBGT LT font EGT. Machine learning models are algorithms designed to learn patterns from data and make predictions or decisions. Sklearn provides a wide range of models like linear regression, decision trees, support vector machines, and more. Python. From sklearn, linear model import linear regression. Create a linear regression model. Model linear regression. Train the model on your data. Model. Fit xtrain. Y-train. Make predictions. Predictions model. Predict xtest. LT font style font size 14px GT LTBGT model training and evaluation LTBGT LT font EGT. Model training involves feeding your model with data and adjusting its parameters to learn underlying patterns. Evaluation is the process of assessing the model's performance on unseen data. Python. From sklearn, metrics import mean squared error. Calculate the mean squared error. Error mean squared error test. Predictions. Print the error. Printf mean squared error. What is the purpose of sklearn, utils, as float array in scikit-learn? This question asks about the functionality of the sklearn, utils, as float array function in the scikit-learn library. It probes the user's understanding of how this function contributes to data manipulation and preparation in machine learning workflows. A. To convert an array-like object to a float array. This choice describes one of the core functionalities of the isFloat array function. B. To reshape an array-like object to a specific shape. This choice highlights another essential capability of the function reshaping data to conform to model requirements. C. To standardize an array-like object to have zero mean and unit variance. This option points to a further application of the function standardization, a data preprocessing technique crucial for improving model performance. D. To perform one-hot encoding on categorical features. While one-hot encoding is a data preprocessing technique, it's not a feature of is float array. This option is incorrect. E. All of the above. This option encompasses all the functionalities listed above and is the correct answer. E. All of the above. As described in the diagram, sklearn, utils, as float array offers all of the functionalities listed in choices A, B, and C, including converting to float arrays, reshaping, and standardizing data. It is a comprehensive function for data preparation within the scikit-learn library. Array-like objects. An array-like object refers to a data structure that behaves similar to an array, allowing you to access elements using indices or perform iterative operations. Common examples include lists, tuples, NumPy arrays, and pandas data frames. In the context of the isFloat function, these objects are the input data that the function transforms into float arrays. Float array. A float array is an array where all elements are represented as floating point numbers. This format is often preferred in machine learning as many algorithms work most efficiently with numerical data, particularly when performing mathematical operations like linear algebra. The isFloat function plays a crucial role in ensuring that the input data is compatible with these algorithms by converting it to the float array format. Data preprocessing. Data preprocessing refers to the process of transforming raw data into a suitable format for use in machine learning models. This often involves cleaning, transforming, or standardizing the data to improve model performance and ensure compatibility. isFloat is a key tool for data preprocessing, allowing you to convert different data types, reshape arrays, and standardize data as needed. Feature engineering. Feature engineering refers to the process of creating or transforming features in your dataset to enhance the performance of machine learning models. Reshaping data, as handled by isFloat, is a common feature engineering technique. For example, you might reshape data for dimensionality reduction algorithms or to prepare data for specific model architectures. This helps to improve the model's ability to extract relevant information from the data. Standardization. Standardization is a data preprocessing technique that scales data to have zero mean and unit variance. It helps to improve the performance of certain machine learning algorithms, especially those that are sensitive to the scale of the data, such as support vector machines (SVM). The isFloat function allows you to perform standardization as part of your data preparation workflow. Let's consider a simple example using NumPy arrays, a common array-like object in machine learning. Assume we have an array containing house prices stored as integers. Python. Import NumPy as NP. From sklearn, utils import isFloat. Prices NP. Array 1500, 2000, 2500, 3000, 350. Using isFloat, we can convert this array to a float array, reshape it, and standardize it. Python. Prices float isFloat prices. D-type float. Print prices float output 150,000. 200, 250, 30, 350,000. Price reshaped isFloat prices. Shape 5, 1 reshape to a 5 by 1 array. Print prices reshaped output 150,000. 2,000, 2,500, 3,000, 350,000. Prices standardized as float array prices. Copy true. Force all finite true. D type float. Print prices standardized output -1.26491106 to 0.6324555530. 0.6324555531.26491106. In this example, as float array performs the required conversions and transformations, making the data ready for use in machine learning algorithms. Which of the following statements is true about the sklearn, utils, as float array function? A. As float array ensures that the input data is converted to a NumPy array of floating point values, handling various input types like lists, tuples, and pandas data frames. B. As float array always preserves the original input data structure, including any multidimensional arrays or matrices. C. As float array automatically handles missing values nans by replacing them with zeros. D. All of the above. A. As float array ensures that the input data is converted to a NumPy array of floating point values, handling various input types like lists, tuples, and pandas data frames. This statement is true as explained in the diagrams block 1. LT font style font size 14px GT LTBGT data type conversion LTBGT as float array handles a variety of input data types, such as lists, tuples, and pandas data frames. It converts them to NumPy arrays of floating point values, making them suitable for use in machine learning models that often require numerical data. True. B. As float array always preserves the original input data structure, including any multidimensional arrays or matrices. This statement is true as explained in the diagrams block 2. LT font style font size 14px GT LTBGT structure preservation LTBGT if the input data is already a multidimensional array or matrix. As float array maintains its structure, ensuring the shape and dimensionality of the data remain consistent. This is essential for preserving relationships between features in your data. True. C. As float array automatically handles missing values nans by replacing them with zeros. This statement is true as explained in the diagrams block 3. LT font style font size 14px GT LTBGT missing value handling LTBGT as float array can automatically handle missing values nans by replacing them with zeros. This is particularly useful when dealing with real-world datasets that might have missing entries. True. D. All of the above. This statement is true as all the above statements are true and are explained in the diagrams block. LT font style font size 16px GT LTBGT XPLA nation LTBGT is float array function in scikit-learn. sklearn, utils, as float array is a utility function designed to convert input data into a NumPy array of floating point values. Here's a breakdown of its functionalities. True. D. All of the above. NumPy arrays are fundamental data structures in Python for numerical computing. They provide efficient storage and manipulation of multidimensional arrays, which are essential for tasks like scientific computing, data analysis, and machine learning. Data structures are ways of organizing data in a computer's memory for efficient access and manipulation. Examples include lists, ordered collections, tuples, immutable collections, and data frames, tabular data with rows and columns. Missing values, often represented as none, not a number, are common in real-world datasets. Handling them appropriately is crucial for maintaining data integrity and avoiding errors in analysis and modeling. Scikit-learn is a powerful Python library for machine learning, providing a wide range of algorithms for tasks like classification, regression, clustering, and dimensionality reduction. Machine learning models are algorithms that learn patterns from data and make predictions or decisions based on those patterns. Examples include linear regression predicting continuous values, support vector machines classifying data, and decision trees making predictions based on a series of decisions. Preparing data for a machine learning model that requires numerical data. You have a dataset of customer demographics stored in a pandas data frame. To use this data to train a model that predicts customer spending, you can use this float array to convert the data frame into a NumPy array of floating point values. Ensuring consistent data representation across different data sources. You are working with data from multiple databases that use different data types. Before combining these datasets, you can use this float array to ensure that all data is represented as floating point numbers, making it easier to integrate and analyze the data. Handling missing values in a real-world dataset. Your dataset has missing values for certain features, like income or age. You can use this float array to automatically replace these missing values with zeros, allowing you to proceed with data analysis and modeling without encountering errors. What is the primary purpose of the scikit-learn function assert all finite? A. To ensure all data points are within a specific range. B. To identify and handle missing values in a dataset. C. To verify that all values in a dataset are finite, not none or infinity. D. To normalize the data to a specific scale, e.g., 0 to 1. The primary purpose of assert all finite is to ensure data integrity. X20. It verifies that all values in the dataset are finite, meaning they are not none. Not a number represents an undefined or unrepresentable value. Infinity represents a value larger than the maximum representable number. This function plays a crucial role in preventing unexpected errors or incorrect results in machine learning models when encountering non-finite values. X20. False. While assert all finite aims to ensure data integrity, it focuses on the finiteness of values, not their range. Ensuring data within a specific range would be a different pre-processing step. The primary purpose of assert all finite is to ensure data integrity. X20. It verifies that all values in the dataset are finite, meaning they are not none. Not a number represents an undefined or unrepresentable value. Infinity represents a value larger than the maximum representable number. This function plays a crucial role in preventing unexpected errors or incorrect results in machine learning models when encountering non-finite values. X20. False. Assert all finite addresses non-finite values none and infinity, not missing values. Handling missing values typically involves techniques like imputation or removal. The primary purpose of assert all finite is to ensure data integrity. X20. It verifies that all values in the dataset are finite, meaning they are not none. Not a number represents an undefined or unrepresentable value. Infinity represents a value larger than the maximum representable number. This function plays a crucial role in preventing unexpected errors or incorrect results in machine learning models when encountering non-finite values. X20. True. This statement accurately describes the core functionality of assert all finite. It checks if all values in the dataset are finite, preventing issues caused by none or infinity. The primary purpose of assert all finite is to ensure data integrity. x20. It verifies that all values in the dataset are finite, meaning they are not. None, not a number, represents an undefined or unrepresentable value. Infinity represents a value larger than the maximum representable number. This function plays a crucial role in preventing unexpected errors or incorrect results in machine learning models when encountering non-finite values. x20. False. Data normalization is a separate preprocessing step aimed at scaling data to a specific range. Assert all finite focuses on ensuring the validity of values, not their scale. C. To verify that all values in a dataset are finite, not none or infinity. LTDIV style font size 14 px GT LTB GTNAN not a number LTB GT LTB RGT a value that cannot be represented numerically, often resulting from invalid operations, e.g. dividing by 0. LTDIV. In Python, dividing by 0 results in none. For instance, 1 O will return none. LTDIV style font size 14 px GT LTB GT infinity LTB GT LTB RGT a value exceeding the maximum representable number in a computer's system. LTDIV. In Python, dividing a very large number by a very small number can lead to infinity. For example, 1e300 1e-300 could potentially result in infinity. LTDIV style font size 14 px GT LTB GT data integrity LTB GT LTB RGT ensuring the accuracy, consistency, and validity of data, crucial for reliable machine learning outcomes. LTDIV. Consider a dataset of patient health records. Data integrity ensures that patient names, ages, and diagnoses are accurate and consistent, preventing errors in medical analysis or treatment decisions. LTDIV style font size 14 px GT LTB GT data preprocessing LTB GT LTB RGT transforming raw data into a suitable format for machine learning models often involves handling missing values, scaling, and outlier detection. LTDIV. Before training a model to predict house prices, preprocessing steps might include handling missing values in features like square footage, scaling features like price and lot size, and detecting and handling outlier values for unusual house sizes. LTDIV style font size 14 px GT LTB GT preventing model errors LTB GT LTB RGT many machine learning algorithms are sensitive to non-finite values, which can lead to incorrect results or crashes. Assert all finite helps to identify and address such issues before training. LTDIV. A linear regression model attempting to calculate a relationship between features might fail or produce incorrect results if the dataset contains none or infinity values. Assert all finite can prevent this by detecting and handling such issues upfront. LTDIV style font size 14 px GT LTB GT ensuring robustness LTB GT LTB RGT by detecting and handling non-finite values. Assert all finite helps to make machine learning models more robust to unexpected data variations. LTDIV. A machine learning model trained on financial data might encounter unexpected outliers or errors due to market fluctuations. Assert all finite can contribute to the model's robustness by ensuring data integrity and handling non-finite values gracefully. LTDIV style font size 14 px GT LTB GT debugging and data cleaning LTB GT LTB RGT. Assert all finite can be used as a data validation step during data preprocessing, helping to identify and fix issues early on. LTDIV. During preprocessing, assert all finite can be used to identify potential data issues that might arise from data import, transformations, or calculations. This early detection facilitates quick debugging in cleaning, improving data quality and model performance. What is the primary purpose of the sklearn function assert all finite in machine learning? To ensure data is within a specific range, like between 0 and 1. To check for missing values in a dataset. To identify and handle outliers in a dataset. To verify that all data points are finite, not none or infinity. All of the above. To ensure data is within a specific range, like between 0 and 1. This is incorrect. Assert all finite does not enforce data range restrictions. Its sole purpose is to ensure that data is finite. False. To check for missing values in a dataset. This is incorrect. While assert all finite can help detect missing values represented as none, not a number, it's not its primary function. It primarily focuses on detecting non-finite values, including none and infinity. False. To identify and handle outliers in a dataset. This is incorrect. Outlier detection and handling are separate processes. Assert all finite doesn't directly handle outliers but checks if values are finite, which can be a step in outlier analysis. False. To verify that all data points are finite, not none or infinity. This is correct. The assert all finite function's primary purpose is to ensure that all data points are finite. This means they are not none, not a number, or infinity, which are invalid numerical values. True. All of the above. This is incorrect. While assert all finite can help detect missing values represented as none, its primary focus is on checking for finite values. It does not address data range or outlier handling. False. To verify that all data points are finite, not none or infinity. None, not a number. None represents a value that is undefined or cannot be represented as a valid number. It's a common result of operations like dividing by 0 or attempting to take the square root of a negative number. In data analysis, none values often signify missing data points. In statistical calculations, encountering none can indicate invalid inputs or errors. 0 none, sqrt1 none. Infinity. Infinity represents a value that is larger than any finite number. It's often the result of operations like dividing a non-zero number by 0 or taking the limit of an unbounded function. In mathematical calculations, infinity can represent unbounded growth or values beyond any finite limit. In computer science, infinity is used to represent values that exceed the maximum representable number. 1O infinity. Data preprocessing. Data preprocessing is the essential step of preparing raw data for use in machine learning models. This involves cleaning, transforming, and scaling the data to improve model accuracy and efficiency, handling missing values, removing outliers, and scaling data to a common range are common data preprocessing steps. Preprocessing can significantly impact the performance of machine learning models by ensuring consistent and meaningful inputs. Scaling a dataset to a range of 0 to 1 using min-max scaling XX, minx-max, minx. Numerical optimization. Numerical optimization involves finding the best set of parameters for a mathematical model. This is often used in machine learning to minimize a loss function and improve model predictions. Gradient descent is a popular numerical optimization algorithm used to train machine learning models. Optimization techniques are used to find the optimal weights and biases in neural networks, minimizing prediction errors. Gradient descent updates model parameters iteratively using the gradient of a loss function to Minimize it. Linear regression. Linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables using a linear equation. Predicting house prices based on square footage, number of bedrooms, and location. Estimating customer spending based on income and demographic information. YMXC, where Y is the dependent variable, X is the independent variable, M is the slope, and C is the intercept. Logistic regression. Logistic regression is a classification algorithm used to predict the probability of a binary outcome 0 or 1 based on independent variables. Predicting customer churn, whether a customer will stop using a service. Classifying emails as spam or not spam. Identifying fraudulent transactions. P11AZ, where P is the predicted probability. Z is the linear combination of independent variables. Support vector machines SVMs. Support vector machines SVMs are powerful classification algorithms that find an optimal hyperplane to separate data points into different classes. Image classification, such as recognizing handwritten digits. Text classification, such as sentiment analysis. Object detection in computer vision. SVMs aim to maximize the margin between the separating hyperplane and the closest data points. Support vectors. Neural networks. Neural networks are complex interconnected nodes neurons that learn patterns and relationships in data, mimicking the human brain. Image recognition, such as identifying objects in photos. Natural language processing, such as machine translation and sentiment analysis. Autonomous driving systems. Neural networks use weighted sums of inputs, activation functions, and backpropagation to learn and adjust parameters. Any model using gradient descent. Gradient descent is a widely used optimization algorithm for training machine learning models. It iteratively updates model parameters to minimize a loss function. Linear regression, logistic regression, and neural networks are often trained using gradient descent. Gradient descent is a foundational algorithm in machine learning, enabling the optimization of a vast range of models. Gradient descent updates parameters iteratively in the direction of the negative gradient of a loss function. Which of the following utilities in scikit-learn are deprecated and no longer recommended for use? A. sklearn, utils, checkarray. B. sklearn, utils, checkrandom state. C. sklearn, utils, safe indexing. D. All of the above. False. sklearn, utils, checkarray is deprecated but still recommended for use, particularly in data preprocessing pipelines. While the checkarray function is still available, it's recommended to use the more robust and feature-rich sklearn, utils, validation, checkarray function instead. False. sklearn, utils, checkrandom state is deprecated, but still recommended for use. Its use is more convenient and less prone to errors than manually creating a random state object. However, it's encouraged to use the more explicit and feature-rich sklearn, utils, validation, checkrandom state instead. False. sklearn, utils, safe indexing is deprecated but still recommended for use. It provides a helpful safeguard against errors when indexing arrays. However, it's recommended to use the more explicit and feature-rich sklearn, utils, validation, safe indexing instead. True. All of the mentioned utilities sklearn, utils, checkarray, sklearn, utils, checkrandom state, and sklearn, utils, safe indexing are deprecated, but still recommended for use as they are not fully removed from scikit-learn yet. X20 however. It's recommended to use the more robust and feature-rich versions of these functions. sklearn, utils, validation, checkarray. sklearn, utils, validation, check random state. And sklearn, utils, validation, safe indexing, respectively. D. All of the above. Deprecation warnings in scikit-learn indicate that certain features are being phased out and will be removed in future versions of the library. This gives users time to transition to recommended alternatives before the features are completely removed. Using deprecated functions like sklearn, utils, checkarray instead of sklearn, utils, validation, checkarray will trigger a deprecation warning, prompting the user to adopt the newer function. The checkarray function from sklearn, utils checks whether an array-like object meets the requirements for use in scikit-learn estimators, such as ensuring the data is 2D, checking for non-values, and handling various data types. Before training a linear regression model, you can use checkarray to ensure that the input features are in a valid format, handling potential issues like missing values or incorrect data types. The checkRandom state function ensures that a random number generator is used consistently, whether it's a seed value, a random state object, or none using the default generator. When splitting data into train and test sets using train test split, you can set a random state value to ensure that the splitting is reproducible, generating the same splits each time. The safe indexing function provides a way to index NumPy arrays safely, handling cases where indices might be out of bounds or when working with sparse arrays. When subsetting data based on a condition like selecting rows with a specific feature value, safe indexing ensures that the operation is performed correctly, even if some indices are out of bounds. What function in sklearn, utils helps you visualize the structure of an estimator in HTML format? A. Estimator APR. B. Estimator visualize. C. Estimator totmail. D. Estimator HTML REPR. False. This function does not exist in sklearn, utils. It's not used for visualizing estimator structure in HTML format. LT font style quote font size 16 px quote gt ltbgta. ltbgt estimator APR. False. This function does not exist in sklearn, utils. It's not used for visualizing estimator structure in HTML format. LT font style quote font size 16 px quote gt ltbgtb. ltbgt estimator visualize. False. This function does not exist in sklearn, utils. It's not used for visualizing estimator structure in HTML format. LT font style quote font size 16 px quote gt ltbgtc. ltbgt estimator totmail. True. The function estimator HTML REPR from sklearn, utils provides a handy way to visualize the structure of an estimator. It generates an HTML representation that outlines the internal components of the estimator, making it easier to understand its underlying structure and how different elements interact. This visualization is particularly useful for debugging, understanding the workings of complex estimators, and gaining insights into their decision-making processes. LT font style quote font size 16 px quote gt ltbgtd. ltbgt estimator HTML REPR. D. Estimator HTML REPR. Understanding the internal workings of an estimator is crucial for effective model development and debugging. LT font style font size 16px GT LTBGT estimator visualization LTBGT LTBRGT LT font style font size 14px understanding the internal workings of an estimator is crucial for effective model development and debugging. LT font GT. An estimator has different components like parameters, fit methods, predict methods, etc. that contribute to its functionality. LT font style font size 16px GT LTBGT estimator structure TBGT LTBRGT LT font style font size 14px GT An estimator has different components like parameters, fit methods, predict methods, etc. that contribute to its functionality. LT font GT. A well-structured HTML output helps visualize the estimator's structure effectively. LT font style font size 16px GT LTBGT HTML representation LTBGT LTBRGT LT font style font size 14px GT. A well-structured HTML output helps visualize the estimator's structure effectively. LT font GT. What is the purpose of the sklearn, utils, gen batches function? A. To generate random samples from a dataset. B. To split a dataset into training and testing sets. C. To iterate over a dataset in batches. D. To perform data preprocessing, such as scaling and normalization. E. To evaluate the performance of a machine learning model. False. This is not the purpose of gen batches. While random sampling is important in machine learning, gen batches focuses on iterating over data in manageable chunks, not generating random samples. Solution explanation. False. This is a task performed by functions like train, test, split in scikit-learn. Gen batches is concerned with data iteration, not splitting into train test sets. Solution explanation. True. This is the core functionality of gen batches. It iterates over a dataset, providing data in smaller batches to improve efficiency and memory management. Solution explanation. False. Data preprocessing is a separate step in the machine learning workflow. While important, gen batches doesn't handle data preprocessing. Solution explanation. False. Model evaluation involves metrics like accuracy, precision, etc. Gen batches focuses on data handling, not model evaluation. Solution explanation. C. To iterate over a dataset in batches. Training large models when training complex machine learning models on extensive datasets. Processing data in batches allows for efficient use of memory and computational resources. Training large models. Data augmentation. Generating batches of augmented data can be a practical way to enrich a dataset and improve model performance. Data augmentation. Online learning. In online learning scenarios where data arrives in a stream, gen batches can handle data ingestion in manageable chunks. Online learning. Batch processing. Dividing a dataset into smaller subsets batches for processing. This is crucial for managing memory and computational resources, especially with large datasets. Batch processing. Dataset iteration. Iterating over a dataset, often in batches, to access and process data. This is a common technique used in machine learning workflows. Dataset iteration. Computational efficiency. Optimizing resource utilization by processing data in smaller chunks, reducing memory pressure and improving processing speed. Computational efficiency. Memory management. Controlling the amount of data loaded into memory at a time. Preventing memory overload, especially when working with massive datasets. Memory management. Large datasets. Datasets that are too large to fit entirely in memory. Batch processing is essential for handling such datasets efficiently. Large datasets. In scikit-learn, what is the purpose of the utils gen batches function? A. To generate random batches of data for training a machine learning model. B. To split a dataset into train and test sets. C. To generate batches of data for efficient model training, especially for large datasets. A. To generate random batches of data for training a machine learning model. False. Utils gen batches does not generate random batches. It generates batches in a sequential order, which is crucial for training machine learning models efficiently. B. To split a dataset into train and test sets. False. In scikit-learn, train test split is used to split a dataset into train and test sets. Not utils gen batches. Utils gen batches focuses on generating data batches for training. C. To generate batches of data for efficient model training, especially for large datasets. True. Utils gen batches is indeed designed for creating data batches to optimize training for large datasets. This allows models to process data in smaller, manageable chunks, enhancing training efficiency and reducing memory usage. C. To generate batches of data for efficient model training, especially for large datasets. Batch gradient descent. An optimization algorithm that updates model parameters using the average gradient calculated over a batch of training data. Epoch. One complete pass through the entire training dataset. Mini batch gradient descent. A variation of batch gradient descent that uses smaller batches of data to update model parameters. Stochastic gradient descent (SGD). An optimization algorithm that updates model parameters based on the gradient of a single data point batch size of 1. Training large language models (LLMs). LLMs like GPT-3 are trained on massive text datasets. Utils gen batches helps process these datasets in manageable chunks for efficient model training. Image classification with large datasets. Training image classification models on vast image datasets like ImageNet can be memory intensive. Utils gen batches efficiently handles the data in smaller batches. What does the function sklearn, utils, genuine slices accomplish in scikit-learn? It generates evenly distributed slices of a given dataset for parallel processing. It creates a uniform distribution of random numbers for statistical analysis. It calculates the optimal number of folds for cross-validation. All of the above. Correct. Genuine slices is designed to divide a dataset into evenly sized chunks, making it ideal for parallel processing. This enables efficient utilization of multiple processes or cores for tasks like model training. Parallel processing. Correct. While genuine slices doesn't directly generate random numbers, it is often used in conjunction with random number generation techniques. When splitting data into slices for parallel processing or cross-validation, random shuffling might be necessary to ensure the slices are representative of the entire dataset. Random number generation. Correct. While genuine slices helps with dividing data into folds for cross-validation, it doesn't determine the optimal number of folds. The choice of the number of folds depends on factors like dataset size and computational resources. Cross-validation. Correct. As explained above, genuine slices contributes to all three aspects: parallel processing, random number generation in combination, and facilitating cross-validation. D. All of the above. D. All of the above. Genuine slices is a utility function in sklearn used to create evenly sized slices of a dataset. This function is helpful for various machine learning tasks like parallel processing and cross-validation. Python. From sklearn, utils import genuine slices. Data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide into 3 slices. Slices list genuine slices len data. 3. Print slices. Output slice 0, 4, none. Slice 4, 7, none. Slice 7, 10, none. Parallel processing divide a large dataset into chunks for concurrent processing on multiple processors or cores to speed up training. Cross-validation splitting data into folds for cross-validation to assess the model's generalization. Performance. Parallel processing is a technique that involves executing multiple tasks concurrently on different processors or cores, significantly reducing the overall processing time. Imagine training a machine learning model on a large dataset. By dividing the data into chunks and processing each chunk on different cores, the training time can be significantly reduced. Training complex machine learning models on large datasets. Image processing tasks like object detection or image segmentation. Scientific simulations involving massive amounts of data. Cross-validation is a technique for evaluating the performance of a machine learning model by dividing the dataset into multiple folds, training the model on a subset of the folds, and testing it on the remaining fold. This process is repeated multiple times, using different folds for training and testing, providing a more robust estimate of the model's performance. Consider a dataset of 100 samples. In 5-fold cross-validation, the dataset is divided into 5 folds of 20 samples each. The model is trained on 4 folds 80 samples and tested on the remaining fold 20 samples. This process is repeated 5 times, each time using a different fold for testing. The average performance across all 5 folds is used to evaluate the model's performance. Evaluating the performance of a machine learning model when data is limited. Choosing the best hyperparameters for a model. Comparing the performance of different machine learning algorithms. Random number generation is a fundamental technique in machine learning and statistics. It is used for various tasks like data shuffling, generating random subsets for training, and simulating random events. Python. Import random. Data 1, 2, 3, 4, 5. Shuffle the data randomly. Random. Shuffle data. Print data. Output a randomly shuffled version of the original list 1, 2, 3, 4, 5. Data shuffling to ensure fairness in training and testing. Generating random subsets for model training. Simulating random events for Monte Carlo simulations. What is the primary purpose of the indexable class in sklearn utilities? A. To provide a way to access data points by index in a dataset. B. To perform efficient data indexing and slicing in various machine learning algorithms. C. To enable indexing and slicing on sparse data structures. D. All of the above. Correct. The indexable class makes data points in a dataset directly accessible by index, facilitating efficient retrieval and manipulation of individual data entries. For instance, you can quickly access the 5th data point in a dataset using indexing. Correct. The indexable class allows for efficient indexing and slicing operations on datasets, which are critical for the performance and flexibility of various machine learning algorithms. This feature enables algorithms to access specific data subsets or perform transformations on data based on indices. Correct. The indexable class handles sparse data structures effectively, allowing indexing and slicing operations even when most values are zero. This is crucial for working with large datasets that contain many missing or irrelevant values, as it allows algorithms to focus on the relevant non-zero entries. Correct. The indexable class encompasses all the functionalities mentioned above, providing a comprehensive solution for efficient data access in machine learning. It ensures that datasets can be indexed and sliced effectively, regardless of data density or structure. D. All of the above. The indexable class is a fundamental component of sklearn, providing a consistent way to access and manipulate data in datasets. Feature engineering extracts specific features from a dataset based on their indices. Model training efficiently select data points for training and validation sets. Data indexing refers to the ability to retrieve specific data points using their position or index in a dataset. Data exploration analyze individual data points to gain insights into dataset characteristics. Data cleaning identify and address issues with specific data entries based on their indices. Sparse data refers to datasets where most values are zero, common in areas like text analysis and recommender systems. Natural language processing representing text documents as sparse vectors of word frequencies. Recommender systems modeling user preferences and item relationships using sparse matrices. The indexable class facilitates a wide range of operations crucial for successful machine learning projects. Efficient access quickly access specific data points for feature engineering, data selection, and model training. Sparse data handling process sparse datasets efficiently, allowing algorithms to focus on relevant non-zero values. Data preprocessing prepare datasets for machine learning algorithms by performing feature selection, data transformation, and normalization. 1, 2, 3, 0, 4, 5, 0, 7, 0, 8, 9, 10. Suppose we have a sparse dataset represented as a list of lists. Using the indexable class, we can access specific elements based on their row and column indices. For example, to retrieve the value at row 1 and column 2, we would use dataset 1, 2, which would return 0. Which of the following best describes the purpose of sklearn? Utils, indexable. A. To provide a way to access data points in a dataset based on their index. B. To ensure that datasets are consistently ordered and have a defined index. C. To efficiently store and retrieve data from large datasets. D. All of the above. A. To provide a way to access data points in a dataset based on their index. True. This is a fundamental purpose of indexable. It allows you to retrieve data points from a dataset by their index, regardless of the underlying data structure. This is similar to how you access elements in a list or array using their numerical position. B. To ensure that datasets are consistently ordered and have a defined index. True. Indexable ensures that data points are consistently ordered and have a defined index. This is crucial for maintaining data integrity and ensuring predictable results during analysis in model training. C. To efficiently store and retrieve data from large datasets. True. Indexable is optimized for handling large datasets efficiently. It provides methods for retrieving data points based on their index, enabling quick and efficient access to data. This helps in maintaining performance even when working with massive datasets. D. All of the above. True. As explained for options A, B, and C, indexable fulfills all of the stated purposes. It provides a versatile and efficient way to manage data, making it an essential tool for data scientists and machine learning practitioners. D. All of the above. Indexable, a fundamental class in sklearn, utils designed to provide a consistent interface for accessing and manipulating data points within datasets. It ensures that data is accessible based on its index, regardless of the underlying format. Data preprocessing indexable can be used to efficiently select specific features or rows based on their indices, facilitating data transformations like scaling, standardization, or feature selection. Suppose you have a dataset with 10 features, and you want to apply standardization to only the first 5 features. You can use indexable to select the first 5 features based on their indices and then apply a standardization transformation to those specific features. Model training and evaluation. It helps in selecting specific samples for training or testing purposes, allowing for the development of more robust models. For example, you could use indexable to split a dataset into training and testing sets, ensuring that both sets have a consistent ordering and defined indices. Data visualization. You can leverage indexable to create custom visualizations by selectively accessing data points based on their indices. You can create a scatter plot of specific data points from a large dataset based on their indices to visualize relationships or patterns. Custom data structures. Indexable is designed to work with diverse data formats, allowing you to integrate custom data structures into your machine learning workflows. You can create your own data structure and use indexable to access data points within it efficiently. Large-scale data handling. Indexable is optimized for efficient handling of large datasets, enabling you to work with massive amounts of data without compromising performance. When working with datasets with millions of rows, indexable helps to retrieve data points quickly and efficiently without causing performance bottlenecks. Indexable, get indexer, a crucial method used to retrieve the indices of data points based on a specified input array. This method efficiently handles various data structures, including lists, arrays, and sparse matrices. Quiz time. Question: what is the purpose of the sklearn, utils, murmurwish 332 function? A. Calculate the mean of a numerical array. B. Generate a random number within a specified range. C. Perform one-hot encoding on categorical features. D. Compute a 32-bit hash value for a given input. False. The sklearn, utils, murmurwish 332 function is not related to calculating the mean of a numerical array. The mean is a statistical measure that finds the average value of a dataset. Hashing, on the other hand, is about generating unique identifiers. False. The sklearn, utils, murmurwish 332 function doesn't generate random numbers. It's designed for deterministic hashing, meaning that given the same input, it always produces the same output. False. One-hot encoding is a data transformation technique used to convert categorical features into numerical representations. It's not directly related to the function of sklearn, utils, murmurwish 332. True. Sklearn, utils, murmurwish 332 calculates a 32-bit hash value using the murmur-hash-3 algorithm. This function is used for generating unique identifiers for data points or features, particularly in scenarios involving hashing techniques for feature engineering or data structures, like hash tables. D. Compute a 32-bit hash value for a given input. Hashing is a technique to convert data into a fixed size string or number hash using a hashing Algorithm. It's essential for indexing, data integrity, and efficient search. Use case. Creating hash tables for fast data lookups. Murmur hash 3 is a non-cryptographic hashing algorithm known for its speed and distribution of hash values. It's widely used in various applications. Use case. Efficiently generating unique identifiers for data in feature engineering. How can you address this imbalance using sklearn? Utils. Resample. A. Using resample to randomly oversample the minority class churn customers to create a balanced dataset. B. Using resample to randomly undersample the majority class non-churn customers to reduce the imbalance. C. Using resample to perform both oversampling and undersampling to achieve a balanced dataset. D. All of the above. D. All of the above. True. LT font style font size 14px GT LTBGT oversample the minority class LTBGT increase the number of instances from the minority class by randomly duplicating existing samples. True. LT font style font size 14px GT LTBGT undersample the majority class LTBGT reduce the number of instances from the majority class by randomly removing samples. True. LT font style font size 14px GT LTBGT combined oversampling and undersampling LTBGT apply both techniques simultaneously to achieve a balanced dataset. True. The sklearn, utils, resample function provides options for oversampling, undersampling, and a combination of both. It is a versatile tool for addressing class imbalance. Class imbalance. This refers to a situation in a dataset where one class has significantly more instances than the other classes, leading to potential bias in machine learning models. Oversampling. A technique to address class imbalance by increasing the number of instances in the minority class. This can involve duplicating existing samples or generating synthetic data. Undersampling. A technique to address class imbalance by decreasing the number of instances in the majority class. This involves randomly removing samples from the majority class. Resampling techniques. Methods used to adjust the class distribution in a dataset. This includes oversampling, undersampling, and combinations of both. sklearn, utils, resample. A function in the scikit-learn library that provides tools for resampling data, including options for oversampling, undersampling, and combined techniques. Machine learning model performance. The effectiveness of a machine learning model in solving a given task. Resampling techniques can improve model performance by addressing class imbalance. Model bias. A tendency of a machine learning model to favor certain outcomes over others. Class imbalance can contribute to model bias. Fraud detection. In fraud detection, fraudulent transactions are typically rare. Oversampling fraudulent transactions can help the model better identify these unusual events and improve its accuracy. Medical diagnosis. Rare diseases often have limited data. Oversampling instances of rare diseases can help the model learn to identify them more effectively, leading to better diagnostic accuracy. Credit risk assessment. In credit risk assessment, low-risk customers typically dominate the dataset. Undersampling low-risk customers can help the model focus on identifying high-risk borrowers, potentially leading to better risk management decisions. Natural language processing (NLP). Text datasets often have imbalanced sentiment classes. Balancing the dataset by resampling can improve the performance of sentiment analysis models, making them more accurate in classifying text into different sentiment categories. 900. 100, 900, 900, 100, 100, 500, 500. In this example, the dataset initially has 900 non-churn customers and 100 churn customers. This imbalance can affect model performance. By oversampling, the number of churn customers is increased to 900, creating a balanced dataset. Undersampling reduces the number of non-churn customers to 100, also resulting in a balanced dataset. A combined approach might reduce the non-churn instances to 500 and increase the churn instances to 500. Each approach has its strengths and weaknesses, depending on the specific context and goals. What is the primary purpose of the safe indexing function in scikit-learn's utils module? Provides a secure way to access data in a NumPy array. Handles indexing operations safely, even when dealing with sparse or non-contiguous data. Ensures data integrity by verifying the validity of indexing operations. All of the above. False. While safe indexing does ensure safe access, its primary purpose is not solely about security. It's about handling complex data structures efficiently. True. This is the core function of safe indexing. It's designed to work reliably with various data formats, including those with sparse or non-sequential elements, avoiding potential errors or unexpected behavior. This is crucial in machine learning, where data can be structured in diverse ways. True. Safe indexing implicitly performs checks to ensure indexing operations are valid and don't lead to data corruption or inconsistencies. This is part of its safety guarantee. True. All the options are correct. Safe indexing provides secure access, handles complex data, and verifies the validity of indexing operations, all contributing to its key purpose of ensuring safe and reliable indexing in scikit-learn. D. All of the above. Ensuring indexing operations are performed correctly, even with complex data structures. In machine learning, you often need to select specific features or samples from your dataset. Safe indexing guarantees this selection is accurate, regardless of the data's structure. Data where most values are zero, often represented efficiently using sparse matrices. Text data or user interactions can be very sparse, e.g., a user might have interacted with only a small fraction of the products in an online store. Safe indexing ensures you can work with this data without issues. Data where elements are not stored sequentially in memory. Data might be stored in a distributed manner or have complex relationships between elements. Safe indexing allows you to access this data effectively and safely. Selecting features or samples for training and testing. Before training a machine learning model, you often need to split your data into training and testing sets. Safe indexing helps ensure this split is accurate and reliable. Splitting data into training, validation, and testing sets. For fine-tuning your machine learning model, you might want to use a validation set to assess its performance. Safe indexing makes this data splitting process efficient and safe. Transforming data to create new features or handle missing values. You might need to add new features based on existing ones, e.g., combining two features or fill in missing values. Safe indexing assists in these transformations while ensuring data integrity. Representing sparse data with a matrix where most values are zero. Consider a dataset of user ratings for movies. Most users haven't rated every movie, so the rating matrix will be sparse. Safe indexing helps extract the ratings for specific users or movies from this sparse matrix without errors. You are working on a machine learning model and need to select a subset of data points based on certain conditions. You have a Boolean array indicating which data points to keep. But some of the indices in this array might be out of bounds of the data. Which function in scikit-learn can you use to safely create a mask that considers only valid indices? A. sklearn, utils, safe indexing. B. sklearn, utils, safe mask. C. sklearn, utils, checkarray. D. sklearn, utils, checkxe. E. All of the above. False. sklearn, utils, safe indexing handles the safe indexing of arrays. But it doesn't directly address the creation of masks. It focuses on safely extracting data points based on index lists. True. sklearn, utils, safe mask specifically checks the provided Boolean mask against the shape of the data. It ensures all indices in the mask correspond to valid positions within the data, preventing potential errors. It then returns a modified mask with only valid indices. False. sklearn, utils, checkarray checks if an array meets the expected format and data type requirements. For scikit-learn models, it doesn't directly deal with creating safe masks. False. sklearn, utils, checkxe checks the input features x and target variable y before training a model. It ensures they are in valid formats and data types. It's not directly related to creating masks for filtering data. False. Only sklearn, utils, safe mask is specifically designed to handle the task of creating safe masks from potentially out of bounds indices. B. sklearn, utils, safe mask. A Boolean array indicating which elements to keep true or discard false. It's like a filter that selects specific data points. Imagine you have an array representing the ages of people ages 25, 30, 18, 45, 22. You want to filter out people under 20. You can use a Boolean mask false, true, false, true, true. Applying this mask, you get ages mask 30, 45, 22. When an index in a mask references an element beyond the valid range of the dataset, leading to errors or unexpected behavior. If you have an array data 10, 20, 30 and a mask true, 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 false, mask 3 is out of bounds because data has only 3 elements. Trying to access data mask would raise an error. A function in scikit-learn that takes a Boolean array mask and the shape of the data as input, and returns a new mask containing only valid indices, using the previous ages array. If you had a mask true, 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 even though mask has 5 elements and ages has 5. sklearn, utils, safe mask, ages, shape would return true, 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 false, false. This ensures the resulting mask only includes indices within the range of the data. Python. Import numpy is np. From sklearn, utils import safe mask. Data np, array 1, 2, 3, 4, 5, mask np, array true, 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 false, true, false, safe mask mask, data, shape, print safe mask, true 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 false false. Which function from the sklearn, utils module calculates the squared Euclidean distance between two arrays, ensuring that the result is safe even when dealing with potential numerical issues like overflow or underflow. A. sklearn, utils, safesca. B. sklearn, utils, Euclidean distance. C. sklearn, metrics, pairwise, Euclidean distances. D. All of the above. Correct. The function sklearn, utils, safesca specifically computes the squared Euclidean distance between two Arrays and employs techniques to handle potential numerical issues like overflow or underflow, making it safe for calculations. This is directly related to the quiz question's requirement for a safe and stable function. Correct. While sklearn, utils, Euclidean distance primarily calculates the standard Euclidean distance not squared. It is commonly used in scenarios where the squared distance is required. Therefore, it can be used to calculate the squared Euclidean distance by simply squaring the result of a function. It might not explicitly address numerical stability as safeSCA, but it can be used for this purpose. Correct. The function sklearn, metrics, pairwise, Euclidean distances efficiently calculates pairwise Euclidean distances including squared distances between multiple arrays. This versatility makes it suitable for situations where the squared Euclidean distance between two arrays needs to be determined. And it offers numerical stability similar to safeSCA when dealing with multiple arrays. Correct. Based on the explanations for the individual choices, all the options A, B, and C can be used to calculate the squared Euclidean distance between two arrays. Therefore, the correct answer is D. All of the above. D. All of the above. Calculating the squared Euclidean distance between two feature vectors in a machine learning model. Optimizing the distance calculation in clustering algorithms for improved efficiency in numerical stability. Using squared distances in nearest neighbor searches for efficient and accurate results. Calculating the distance between two data points in a k-nearest neighbors KNN classification algorithm. Determining the distance between two clusters in a k-means clustering algorithm. Evaluating the similarity or dissimilarity between two samples in a dimensionality reduction technique like principal component analysis (PCA). Calculating the distance matrix between a set of data points for efficient pairwise comparisons in various machine learning algorithms. Computing the distance between all pairs of images in a dataset for image retrieval or classification. Finding the nearest neighbors in a large-scale dataset efficiently for recommendation systems or anomaly detection. The straight line distance between 2 points in a multidimensional space. It's calculated using the Pythagorean theorem. Consider 2 points in a two-dimensional space. A2, 3 and B5, 7. The Euclidean distance between these points is calculated as follows. 5, 2, 7, 3, 3, 4, 2, 5, 5. This means points A and B are 5 units apart. Ensuring that calculations are accurate and avoid errors due to issues like overflow exceeding k maximum representable value or underflow becoming too small to be represented. Imagine calculating the sum of a large number of very small values. Due to underflow, these small values might be rounded to 0, leading to an inaccurate sum. Numerical stability techniques aim to prevent such errors by handling very small or large values appropriately. Which of the following statement is correct for sklearn? Utils, shuffle in Python. Shuffles the data randomly and returns the shuffled data. Shuffles the data randomly and returns the shuffled data as well as the corresponding indices. Shuffles the data randomly in place. All the above. Partially correct. This is partially correct as it shuffles the data randomly and returns the shuffled data. But it also has the option to return indices. Partially correct. This is partially correct as it shuffles the data randomly and returns the shuffled data as well as the corresponding indices. But it also has the option to shuffle in place. Partially correct. This is partially correct as it shuffles the data randomly in place. But it also has the option to return shuffled data and indices. Correct. This is the correct answer. sklearn, utils, shuffle can perform all the above mentioned actions. The function allows you to shuffle data randomly. Return the shuffled data, return the corresponding indices, or perform the shuffling in place. D. All the above. sklearn, utils, shuffle. This function shuffles data randomly and returns the shuffled data. It can also return the shuffled indices for the data. Python. From sklearn, utils import shuffle. Data 1, 2, 3, 4, 5. Shuffled data. Shuffled indices shuffle data. Random state 42. Print shuffled data output 3, 2, 5, 4, 1. Print shuffled indices output 2, 1, 4, 3, 0. In place shuffling. The data is shuffled directly within the original data structure, without creating a new copy. Python. From sklearn, utils import shuffle. Data 1, 2, 3, 4, 5. Shuffle data. Random state 42. In place true. Print data output 3, 2, 5, 4, 1. Randomness. Shuffling is done randomly using a random number generator. Python. From sklearn, utils import shuffle. Data 1, 2, 3, 4, 5. Shuffle data. Random state 42. Print shuffle data output 3, 2, 5, 4, 1. The random state parameter ensures that the shuffling is deterministic and reproducible, making it easier to debug and compare results. Machine learning models. Shuffling data is crucial for training machine learning models to prevent bias due to data order. In a dataset where the data is ordered chronologically, training a model on this data without shuffling could result in the model learning temporal patterns instead of the true underlying relationships. Shuffling helps break this pattern and ensures that the model learns from a random distribution of data. Data exploration. Shuffling data helps in randomly sampling and analyzing subsets of data for better insights. Imagine you have a large dataset and you want to understand the distribution of a certain feature. Instead of analyzing the entire dataset, you can shuffle it and then randomly sample a smaller subset to get a quick estimate of a distribution. Data augmentation. By shuffling data, you can create variations of the data for training models, improving their robustness. Shuffling can be used for augmenting data for image classification tasks. By randomly shuffling the pixels of an image, you can create variations of the image that are still similar to the original image but have different pixel arrangements. This helps the model learn to recognize the image regardless of minor variations in its appearance. What are the advantages of using sklearn, utils, validation functions like checkarray, assert all finite, and check consistent length? A. Ensures data consistency and prevents unexpected errors. B. Improves model performance by optimizing data formatting. C. Provides efficient data transformations for specific milliliter algorithms. D. All of the above. This is correct. The validation functions help in maintaining data integrity, preventing errors, and ensuring the data is ready for machine learning. For example, checkarray can check if a dataset contains missing values. And if it does, it raises an error or fills in the missing values with a suitable strategy. This ensures the data is clean and consistent. This is correct. Consistent data formatting and structure, ensured by validation functions, can indirectly lead to better model performance as the algorithm is not burdened with dealing with inconsistent data. For instance, the check consistent length function guarantees that all arrays have the same number of samples. This is crucial for algorithms like linear regression, where data points with inconsistent dimensions could introduce bias. This is incorrect. While validation functions are essential, they primarily focus on data quality and consistency, not on specific data transformations. Specific milliliter algorithms typically have their own transformers for preparing data according to their specific needs, like standard scaler for scaling data or one-hot encoder for categorical feature encoding. This is correct. As explained in the previous statements, the validation functions contribute to data consistency, prevent errors, and indirectly improve performance by ensuring data quality. D. All of the above. The process of verifying the quality, consistency, and format of data. This is crucial in machine learning as data is often collected from different sources, and it might be in inconsistent formats or contain errors. Validation ensures that the data is ready for analysis and model training. Example: imagine you are building a machine learning model to predict customer churn. You have customer data from various sources. One source might have age as an integer while another source might have age as a string. Data validation would identify these inconsistencies and ensure that age is represented uniformly throughout your data. Suppose you have a dataset for predicting house prices with features like square footage, bedrooms, bathrooms, and age. You are using a linear regression model, which requires numerical data. Data validation would ensure that all features are numerical. This helps to avoid errors like attempting to use categorical data, e.g., old instead of age in years with a linear regression model, ensuring data conforms to predefined rules and standards. This includes things like making sure that all features have the same number of data points, e.g., the same number of rows in a table, similar data types, and consistent formatting. Example: consider a dataset for loan applications. Each application should have the same set of features like income, credit score, loan amount, etc. Data consistency ensures that all applications have the same information, preventing errors in analysis and model training. Suppose you have two datasets, one for training a model and one for testing it. Data consistency is crucial to ensure both datasets have the same features, e.g., both datasets should have the same columns and the same number of data points, e.g., the same number of rows to avoid unexpected results during model testing. Making sure data aligns with the requirements of milliliter algorithms. This ensures that the data format and structure are suitable for the chosen algorithm. For example, some algorithms require numerical data, while others can handle categorical data. Example: you are building a recommendation system for movies. You have a dataset with information like movie genre, release year, and ratings. Some algorithms might need the genre to be encoded numerically. Data compatibility ensures that the data is processed and formatted correctly for the chosen algorithm to work effectively. You are using a k-nearest neighbors algorithm for image classification. The algorithm requires image data to be represented as a matrix of pixel values. Data compatibility would ensure that the images are converted to the correct format before feeding them into the model. Which of the following is not a function provided by sklearn's validation module for splitting data into train and test sets? A. Train test split. B. K-fold. C. Stratified K-fold. D. Shuffle split. E. All of the above. False. The train test split function is a core part of sklearn's validation module, designed to split data into training and testing sets for model evaluation and development. It provides a straightforward way to divide your data into distinct subsets. enabling the training of a model on one part of the data and testing its performance on the unseen data. False. The k-fold function is a powerful tool for cross-validation within sklearn's validation module. It allows you to partition your data into k-equal-sized folds and iteratively use k1 folds for training and the remaining fold for testing. This approach provides robust model evaluation by assessing performance across multiple training testing splits, mitigating the risk of overfitting and generating more reliable performance estimates. False. The stratified k-fold function, also within sklearn's validation module, is specifically tailored for preserving class proportions during data splitting. When dealing with datasets where class imbalances exist, this method ensures that the distribution of classes within each fold mirrors the original dataset, preventing biases in model evaluation. False. The shuffle split function in sklearn's validation module is used to create multiple train test splits with random shuffling. It provides flexibility in specifying the number of splits and the size of the training and testing sets, allowing you to explore various combinations and potentially improve model generalization. True. All of the mentioned functions train test split, k-fold, stratified k-fold, and shuffle split are integral components of sklearn's validation module, providing diverse strategies for splitting data into training and testing sets for robust model development and evaluation. All of the above. Train test split. The most basic technique in data splitting involves dividing the dataset into two distinct subsets: the training set and the testing set. The training set is used to train the machine learning model, while the testing set is used to evaluate the model's performance on unseen data. This approach helps assess the model's ability to generalize to new, previously unseen data, providing a realistic evaluation of its predictive capability. K-fold cross-validation. K-fold cross-validation is a powerful technique for evaluating machine learning models. It involves dividing the data into k-equal-sized folds. The model is then trained on k1 folds and evaluated on the remaining fold. This process is repeated k times, with each fold serving as the testing set once. The final performance metric is the average performance across all k iterations. This method helps to mitigate the risk of overfitting and provides a more robust evaluation of model performance. Stratified k-fold cross-validation. Stratified k-fold cross-validation is a variation of k-fold cross-validation specifically designed for datasets with class imbalances. It ensures that the distribution of classes within each fold mirrors the original dataset. This approach prevents biases in model evaluation by preserving the relative proportions of different classes within the folds. By ensuring a balanced representation of classes in each fold, stratified k-fold cross-validation leads to more reliable model performance assessments. Shuffle split. Shuffle split is a method for generating multiple train test splits with random shuffling. It provides flexibility by allowing you to specify the number of splits and the size of training and testing sets. This approach is particularly useful when exploring different combinations of training and testing sizes to optimize model performance and generalization. By creating multiple splits with random shuffling, shuffle split helps reduce the impact of any inherent order in the data, leading to more robust model evaluations. Model evaluation. Evaluating a machine learning model's performance is crucial for determining its effectiveness. The validation functions in sklearn are used to split the data into training and testing sets. This allows the model to be trained on the training set and then its performance to be evaluated on the unseen testing set. This process provides insights into the model's ability to generalize to new data, which is vital for making accurate predictions. Hyperparameter tuning. Hyperparameter tuning involves finding the optimal set of hyperparameters for a machine learning model. The validation functions in sklearn are used to split the data into training and validation sets. The model is trained on the training set with different hyperparameter values, and its performance is evaluated on the validation set. By repeating this process for different hyperparameter combinations, the best set of hyperparameters can be identified, leading to improved model performance. Feature selection. Feature selection involves identifying the most relevant features from a dataset for building a machine learning model. The validation functions in sklearn can be used to split the data into training and testing sets. By evaluating the model's performance with different feature subsets on the testing set, the most informative features can be identified. This helps in building a model that is more accurate, efficient, and interpretable. What does the sklearn, utils, checkexe function do in scikit-learn? A. Checks if the input data X and target values Y are valid for use in scikit-learn models. This includes checking for correct data types, shape, and missing values. B. Converts input data X to a specific format, such as a NumPy array, before feeding it to a model. C. Calculates the accuracy of a model on the provided input data X and target values Y. D. All of the above. A. Checks if the input data X and target values Y are valid for use in scikit-learn models. This includes checking for correct data types, shape, and missing values. True. This is one of the key functions of checkexe. It ensures that the input features X and target values Y meet the requirements for scikit-learn models. This includes checking for correct data types like numerical or categorical, the expected shape of the data e.g., 2D array for features, and the absence of missing values. If any of these checks fail, the function raises an exception. B. Converts input data X to a specific format, such as a NumPy array, before feeding it to a model. True. Along with data validation, checkexe converts the input data X to a NumPy array. This is important because scikit-learn models generally expect data in the form of NumPy arrays. This conversion ensures consistent data representation across different input data formats. C. Calculates the accuracy of a model on the provided input data X and target values Y. False. This is incorrect. The checkexe function is not responsible for calculating model accuracy. Model accuracy is typically determined using evaluation metrics like accuracy score, precision, recall, etc., which are calculated after training the model. Checkexe is focused on data preprocessing and validation, not model evaluation. D. All of the above. True. This is the correct answer. As explained above, checkexe performs data validation, data conversion, and error handling to ensure compatibility with scikit-learn models. It prepares the data before it is fed to the model for training or prediction. D. All of the above. Data types. Understanding different data types in Python, e.g., NumPy arrays, pandas data frames is essential when working with machine learning data. Scikit-learn models often require specific data types, such as NumPy arrays. For example, a linear regression model expects numerical features, which are typically represented using NumPy arrays. Understanding data types helps you ensure that your data is compatible with the chosen model. Data shape. Recognizing the dimensions of your data, e.g., number of rows and columns in a dataset, is crucial for model compatibility. Models have specific input requirements regarding the shape of the data. A model might expect features in a 2D array, where each row represents an observation and each column represents a feature. If the shape of your data doesn't match the model's expectations, you might encounter errors or unexpected behavior. For example, a logistic regression model typically expects a 2D array of features and a 1D array of target values. Missing values. Handling missing data is a critical aspect of data preparation for machine learning models. You can use techniques like imputation or dropping missing values. Missing values in data can pose challenges for models. Techniques like imputation, replacing missing values with estimated values, or dropping rows columns with missing values are common approaches to handle them. Failing to address missing values can lead to inaccurate model predictions. NumPy arrays. NumPy is the fundamental library for numerical computing in Python, and checkxc often converts data to NumPy arrays. NumPy arrays provide efficient storage and operations on numerical data, which is essential for machine learning. The checkxc function uses NumPy arrays as the standard data format for scikit-learn models, ensuring consistency and ease of processing. Python. From sklearn, utils import checkxc. Import pandas as PD. From sklearn, linear model import logistic regression. Load data from a CSV file. Data PD, read CSV your data.csv. Separate features X and target Y. X data, drop target column. Access 1. Y data target column. Use checkxc for data validation. X, Y checkxx, Y. Create and train a logistic regression model. Model logistic regression. Model, fitx, Y. Make predictions. Predictions model, predictix. This code snippet demonstrates the use of checkxc in a typical machine learning workflow. 1. Data loading. The example loads data from a CSV file using pandas. 2. Feature and target separation. The features X are separated from the target variable Y using data, drop and indexing. 3. Data validation and conversion. The checkxc function is applied to ensure data integrity and convert the features to a NumPy array. 4. Model training and prediction. A logistic regression model is created, trained on the validated data, and used to make predictions on the same features. Suppose you have a dataset with 100 observations and 5 features X and a target variable Y, representing binary classification 0 or 1. You can use checkxc to validate this data before training a model. Python. From sklearn, utils import checkxc. X NP, random, rand 100. 5 simulated features. Y NP, random, randint 0. 2. Size 100 simulated target values. X, Y checkxx, Y. Now X will be a NumPy array of shape 100. 5. And Y will be a NumPy array of shape 100. In this example, checkxc ensures that the input data X is a 2D array of floating point numbers and the target variable Y is a 1D array of integers. This consistency is essential for training a model like logistic regression, which is the primary function of the checkarray function in scikit-learn's utils module. To convert a list or a NumPy array into a pandas data frame. To ensure that input data is in a suitable format for scikit-learn algorithms. To perform dimensionality reduction on a dataset. To calculate the accuracy of a machine learning model. False. While pandas data frames are commonly used in data analysis, the checkarray function doesn't focus on data frame conversion. Its purpose is to ensure data compatibility with scikit-learn algorithms, which often prefer NumPy arrays. True. This is the core function of checkarray. It verifies data types, shapes, and other properties to guarantee that the input data aligns with the requirements of scikit-learn algorithms, preventing errors and ensuring smooth operation. False. Dimensionality reduction is a distinct technique handled by separate functions within scikit-learn, like PCA principal component analysis. Checkarray is not directly involved in reducing the number of features in a dataset. False. Evaluating model performance, including accuracy, is done using dedicated metrics and scoring functions in scikit-learn. The checkarray function focuses solely on preparing data for model training and prediction, not on evaluating model outcomes. B. To ensure that input data is in a suitable format for scikit-learn algorithms. Scikit-learn algorithms typically work with structured data, often represented as NumPy arrays, lists, or sparse matrices. Checkarray verifies that the input data adheres to these expected types. If you have a list of numbers representing your data, checkarray might convert it to a NumPy array for compatibility with a linear regression model. Data from various sources, like CSV files or databases, may come in different formats. Checkarray ensures that these data are appropriately transformed for consistent processing. The shape of data refers to its dimensions, rows, samples, and columns features. Checkarray checks for consistency in these dimensions, ensuring compatibility with the algorithm's expectations. A classification algorithm might require data with a specific number of columns features to represent the different attributes used to predict the class labels. Checkarray enforces these dimensional requirements. In image processing, data might be in the form of multi-dimensional arrays representing pixel values. Checkarray ensures that these arrays have the correct dimensions for image-specific algorithms. Data can have various properties, such as the presence of missing values or the scaling of data values. Checkarray can be configured to handle these properties, ensuring a clean and reliable dataset. If you have a dataset with missing values, checkarray might handle them by imputing with appropriate methods before feeding the data to a model. In financial analysis, data might require normalization or scaling to avoid bias from features with vastly different ranges. Checkarray can enforce these scaling requirements to ensure data fairness. Scikit-learn offers a wide range of algorithms for classification, regression, clustering, and other tasks. Checkarray plays a crucial role in ensuring that data is ready to be used with these algorithms. When training a support vector machine SVM for classification, checkarray ensures that the input data is in a format compatible with SVM's optimization techniques. In medical diagnosis, algorithms like random forests or k-nearest neighbors require properly structured data for accurate predictions. Checkarray helps in preparing data for these algorithms, ensuring consistent and reliable results. Question: which of the following best describes the purpose of the sklearn utils checkscaler function? A. Validates if a given input is a scalar value. B. Converts any input to a scalar value. C. Checks if a given input is a valid scalar value for use in scikit-learn algorithms. D. All of the above. A. Validates if a given input is a scalar value. Correct. The checkscaler function indeed validates if a given input is a scalar value. It ensures that the input is a single numerical value and not an array, list, or other multidimensional structure. It checks if the input is a single number, which is a fundamental requirement for many scikit-learn algorithms. B. Converts any input to a scalar value. Incorrect. Checkscaler does not convert any input to a scalar value. It only checks if the provided input is already a valid scalar. If the input is not a scalar, it raises an error, indicating that the input format is not suitable. C. Checks if a given input is a valid scalar value for use in scikit-learn algorithms. Correct check scalar goes beyond simply validating whether the input is a scalar. It also checks the data type of the scalar to ensure its compatibility with scikit-learn algorithms. This data type validation helps prevent errors during model training or prediction, ensuring smooth operation within the scikit-learn ecosystem. D. All of the above. Correct as explained above. Checkscaler validates the input as a scalar, checks its data type for compatibility, and therefore ensures its suitability for use within scikit-learn algorithms. Hence, it fulfills all the descriptions provided in options A, B, and C. D. All of the above. Scalar values. A scalar value represents a single numerical entity, unlike arrays or matrices which hold multiple values. In the context of machine learning, scalars are often used to represent model parameters, hyperparameters, or individual data points. Data type validation. Data type validation ensures that the data used in algorithms conforms to the expected format. This is crucial for preventing unexpected errors and maintaining the integrity of data processing and model execution. For example, a machine learning algorithm might expect numerical features, and data type validation would ensure that only numerical data is provided to it. Scikit-learn algorithms. Scikit-learn provides a comprehensive library of machine learning algorithms for various tasks like classification, regression, clustering, and dimensionality reduction. These algorithms are designed to operate on data that meets specific formatting and data type requirements, making checkscaler essential for data compatibility. Input data consistency. Input data consistency refers to the uniform format and structure of data fed into machine learning algorithms. This consistency is vital for reliable training and prediction. Checkscaler plays a role in maintaining data consistency by ensuring that input values are scalars with the appropriate data type, thus reducing the chances of errors and inconsistencies. Model hyperparameter tuning. Hyperparameters control the learning process of a machine learning model. Often, these hyperparameters are scalar values like learning rate, regularization strength, or the number of trees in a random forest. Using checkscaler ensures that the chosen hyperparameter values are valid and suitable for the algorithm, promoting better model performance and reducing the risk of unexpected behavior. Feature scaling. Feature scaling is a preprocessing step that transforms the range of numerical features in a dataset. This can be important for algorithms sensitive to feature scaling, such as those based on distance measures. Checkscaler can help ensure that individual features being scaled are indeed scalar values, as expected during feature transformation. Data preprocessing. Data preprocessing is a crucial step in preparing data for machine learning. It involves tasks like handling missing values, cleaning noisy data, and transforming features. Checkscaler can be employed to ensure that individual values being manipulated during preprocessing are scalar values, maintaining data consistency and preventing issues during further processing. For example, suppose you are using a linear regression model from scikit-learn to predict house prices based on size and location. Let's say you are tuning the regularization strength, a hyperparameter for the model. If you provide a list of values for the regularization strength, e.g., 0.1, 0.5, 1.0, checkscaler will raise an error because this is not a scalar value. You need to provide a single value for the regularization strength, e.g., 0.5. Which check scalar will validate as a valid scalar? What is the primary purpose of the sklearn, utils, check consistent length function? A. To ensure that all input arrays have the same number of rows. B. To check for missing values in input arrays. C. To scale input arrays to a common range. D. To convert categorical features to numerical representations. E. All of the above. A. To ensure that all input arrays have the same number of rows. The LT font style font size 16 px sklearn, utils, check consistent length LT font GT function. Verifies that all input arrays have the same number of samples rows. This is crucial for many machine learning algorithms that operate on data where each row represents an independent observation. The function ensures that the data is structured consistently, preventing errors and unexpected behavior during model training or prediction. B. To check for missing values in input arrays. This task is not directly related to the function's purpose. Detecting missing values is typically handled by other preprocessing techniques. C. To scale input arrays to a common range. Scaling data to a common range is also a separate preprocessing step and not the core function of LT font style font size 16 px GT check consistent length LT font GT. D. To convert categorical features to numerical representations. Encoding categorical features is another preprocessing task that is not directly related to the function's focus on consistent data lengths. E. All of the above. Since options B, C, and D are incorrect, this option is also incorrect. Imagine you are training a linear regression model. You have two arrays, one for the features X and another for the target variable Y. The feature array X might have 100 rows, while the target array Y has only 50 rows. In such a scenario, LT font style font size 16 px GT check consistent length LT font GT would raise an error, highlighting that the data is incompatible for training. Consistent length. All input arrays should have the same number of rows or samples, representing independent observations in the data. The length refers to the number of rows. Data consistency. Ensuring that data used for machine learning tasks is structured and formatted correctly. This includes consistent dimensions, data types, and meaningful features. Machine learning algorithms. These algorithms work on data where each row represents an independent observation. Consistency in data dimensions is essential for their proper functioning. Error prevention. By checking for consistent length, the LT font style font size 16 px GT check consistent length LT font GT function helps avoid potential issues like mismatched data points, leading to more reliable model training and prediction. sklearn, utils, check array. This function checks that an array has the correct data type, shape, and dimensionality. sklearn, model selection, train test split. This function splits data into training and testing sets, ensuring consistent lengths for both sets. Data preprocessing. This involves preparing data for machine learning models, including tasks like handling missing values, scaling features, and encoding categorical data. Data validation. Checking the quality and integrity of data, ensuring it meets the requirements for the intended machine learning task. Quiz. How does check random state in scikit-learn handle random number generation? A. It always generates a new random number generator for each call. B. It only generates a new random number generator if none is passed. C. It uses a predetermined seed for all calls if no argument is provided. D. It can accept an integer, a random state instance, or none. E. All of the above. This is not entirely true. While checkRandomState can create new random state instances, it doesn't do so for every call. It depends on the input provided. Incorrect. This is partially correct. CheckRandomState generates a new random state when none is passed. But it also creates a new instance if an integer is given. Partially correct. This is incorrect. When no argument is provided, i.e., none, it uses the system time as the seed, leading to a different random sequence each time. Incorrect. This statement accurately describes the accepted input types for checkRandomState. It can handle integers for seeding, random state objects for direct use, or none for system time-based seeding. Correct. This is the correct answer. CheckRandomState can generate a new random state instance, use an existing instance, or use the system time as the seed, depending on the input provided. Therefore, all the statements above are true. Correct. E. All of the above. Random number generators (RNGs) are algorithms that produce sequences of numbers that appear random. These numbers are used in various applications, including simulations, cryptography, and machine learning. In simulations, RNGs are used to model random events, such as coin flips or dice rolls. In cryptography, they are used to generate secure keys and randomize data. In machine learning, RNGs are often used to initialize model parameters and shuffle data for training. In sklearn, random state is a class that encapsulates a random number generator. It provides methods for generating random numbers, such as randint, rand, and randn. When using sklearn algorithms that rely on randomness, you can use random state to control the seed and ensure reproducibility of results. For example, you can pass a random state object to a model's constructor to initialize its parameters with a specific seed. A seed is an initial value used to start a random number generator. The same seed will always produce the same sequence of random numbers. This is helpful for ensuring reproducibility of results in experiments or simulations. In a machine learning experiment, you might want to use the same seed for random number generation across different runs to ensure that the only difference between the runs is the specific hyperparameters you are tuning. This helps isolate the impact of different hyperparameters on the model's performance. A deterministic process always produces the same output given the same input. A non-deterministic process can produce different outputs even with the same input due to factors like randomness or external influences. In the context of checkRandomState, passing an integer makes the behavior deterministic because the same seed will produce the same sequence of numbers. When you need to ensure that your machine learning model produces the same results every time you run it, you can use a deterministic random number generator by providing a fixed seed. This is useful for debugging and ensuring reproducibility of results. However, if you want to introduce randomness into your model to explore different possibilities, you can use a non-deterministic generator. The checkRandomState function is a utility function in sklearn that handles the management of random number generation. It takes an input that can be an integer seed, a random state instance, or none system time. This function ensures flexibility in controlling randomness in various parts of sklearn. Algorithms and workflows. In machine learning, you might use checkRandomState in these ways. Model initialization. When creating a machine learning model, you can use checkRandomState to specify a seed for the random number generator used to initialize the model's parameters. This ensures that the model is initialized with the same set of parameters every time. which can be helpful for reproducibility. Data shuffling before training a model. You might want to shuffle the data to ensure that the model is exposed to a variety of examples. During training, you can use checkRandomState to specify a seed for the random number generator used to shuffle k data. Cross-validation. When performing cross-validation, you need to split the data into different folds for training and testing. You can use checkRandomState to specify a seed for the random number generator used to split k data. This ensures that the data is split consistently across different runs of the cross-validation process. The checkRandomState function finds its use in various scenarios related to randomness in machine learning. Its flexibility allows for better control over randomness, ensuring reproducibility, exploring diverse possibilities, and managing randomness in data transformations and model training. Here are some specific examples of real-time use cases. 1. Model training with random initialization. Many machine learning algorithms involve random initialization of parameters. You can use checkRandomState to control the initial values of parameters for a consistent model training process. For example, in a neural network, you can set a seed to ensure that the weights are initialized with the same values across different runs of the training process. This helps to reduce variability in the training process and allows you to compare the performance of different hyperparameter settings. 2. Data augmentation. Data augmentation techniques, such as image rotation, cropping, or flipping, often involve random elements. By using checkRandomState, you can control the randomness in these transformations, ensuring consistent data augmentation across different runs of the training process. This is important for reproducibility and for comparing the performance of different data augmentation strategies. 3. Cross-validation. When performing cross-validation, you split the data into folds for training and testing. checkRandomState helps ensure consistent data splitting across different runs of k cross-validation process, which is crucial for obtaining reliable performance estimates. You can specify a seed to ensure that the same data is used for training and testing in each fold across multiple runs. 4. Feature selection. Some feature selection methods rely on random sampling or permutation of features. checkRandomState allows you to control the randomness in these processes, ensuring that the feature selection results are reproducible. This is important for comparing the performance of different feature selection methods. 5. Reproducibility in research and development. It is important to be able to reproduce the results of experiments. Using checkRandomState to specify a seed for random number generation helps ensure that the same sequence of random numbers is used across different runs of an experiment. This makes it much easier to reproduce the results and to compare the performance of different algorithms or hyperparameter settings. 6. Randomized search in hyperparameter tuning. When tuning the hyperparameters of a machine learning model, it is often necessary to search through a large space of possible values. Randomized search is a common technique for this task, which involves randomly sampling hyperparameter values from the search space. checkRandomState can be used to control the randomness in the sampling process, ensuring that the same hyperparameter values are sampled across different runs of the search. Imagine you are training a machine learning model to recognize images of cats and dogs. The model has a layer of neurons that need to be initialized with random weights. Let's say we want to use a seed of 42 to ensure that the weights are initialized with the same values each time we train the model. We can use checkRandomState to set the seed. Python. From sklearn, utils import checkRandomState. Create a random state object with seed 42. Random state check random state 42. Initialize the model's weights using the random state object. Weights random state, rand 100. In this example, check random state creates a random state object that is seeded with the value 42. This ensures that the rand method of the random state object generates the same sequence of random numbers each time we call it. This helps to ensure that the model is initialized with the same set of weights each time we train it, which can be helpful for debugging and for comparing the performance of different hyperparameter settings. What is the purpose of sklearn, utils, validation, check is fitted? A. To check if a model has been trained. B. To check if a model has been fitted to data. C. To check if the model parameters are correctly initialized. D. To check if the data is correctly formatted for the model. B. To check if a model has been fitted to data. Incorrect. While training is a part of the process, check is fitted specifically focuses on whether the model has been exposed to data, not just the existence of a training process. Correct. The check is fitted function ensures that a model has been trained on data before applying methods like predict, transform, or score. This prevents applying these methods to untrained models. Incorrect. Model parameter initialization is separate from the fitting process. Check is fitted doesn't verify parameter initialization. Incorrect. Data formatting is usually handled during pre-processing before fitting. Check is fitted doesn't check data format directly. The check is fitted function is directly related to model fitting. It ensures that the model has been trained on data, which is a critical aspect of the fitting process. While not explicitly checking for evaluation, check is fitted contributes indirectly to model evaluation. By ensuring a trained model, it allows for meaningful evaluation on unseen data. The check is fitted function plays a crucial role in model prediction. By verifying that the model has been fitted to data, it guarantees that predictions are based on learned patterns and not on untrained models. Imagine you have a linear regression model with the following data: X independent variable 1, 2, 3, 4, 5, Y dependent variable 2, 4, 6, 8, 10. The model is fitted using this data to find the relationship between X and Y. Now, if you call predict on the model without fitting it to data, you'll get an error indicating the model is not fitted. Check is fitted ensures that you can only make predictions using the fitted model. The check is fitted function in this example will ensure that the model has been trained on A provided X and Y data before making any predictions. It will verify that the model has learned the pattern between X and Y, enabling accurate predictions. Consider a spam detection model trained to classify emails as spam or not spam. Without check is fitted, you could accidentally classify new emails using an untrained model. This could lead to incorrect predictions, potentially classifying legitimate emails as spam or vice versa. The check is fitted function ensures that the model is trained on a sufficient amount of spam and non-spam emails before making predictions. This significantly reduces the risk of misclassifications, improving the spam detection accuracy. What is the primary purpose of check memory within sklearn, utils, validation? A. Ensures data is stored in memory before model training. B. Prevents memory leaks by identifying and releasing unused memory during model execution. C. Validates data types and shapes to ensure compatibility with machine learning models. D. Caches data in memory to speed up subsequent model training or predictions. Incorrect. Check memory is not primarily focused on ensuring data is stored in memory. Its purpose is to optimize data access, not to enforce a particular memory state. A. Ensures data is stored in memory before model training. Incorrect. While check memory does indirectly contribute to memory efficiency by reducing unnecessary data loads, its core function is caching, not explicit memory leak prevention. B. Prevents memory leaks by identifying and releasing unused memory during model execution. Incorrect. Data type and shape validation is typically handled by other functions within sklearn, utils, validation, not by check memory. C. Validates data types and shapes to ensure compatibility with machine learning models. Correct. Check memory acts as a caching mechanism. It stores data in memory to avoid repeated disk access, which can significantly enhance the speed of training and prediction, especially when dealing with large datasets or frequent data access. D. Caches data in memory to speed up subsequent model training or predictions. D. Caches data in memory to speed up subsequent model training or predictions. Data caching involves storing frequently accessed data in memory for faster retrieval, reducing disk I/O operations. It's essential for improving performance in applications where data is frequently reused, like web servers, database systems, and machine learning models. Imagine a website displaying product information. Caching frequently accessed product details in memory significantly reduces the time it takes to load a product page, enhancing user experience. Memory management deals with allocating and managing memory resources efficiently. It involves techniques like garbage collection, memory allocation, and the allocation, ensuring that available memory is used optimally without running into memory leaks or crashes. A web browser uses memory management to handle multiple open tabs, each containing a different website. Efficient memory management ensures that the browser can seamlessly switch between tabs without experiencing slowdowns or crashes. Disk I/O optimization aims to minimize the time taken for reading and writing data to and from disk. Strategies include caching data in memory, using faster storage devices, and employing optimized file system structures. In a database management system, caching recently accessed data in memory reduces the need to read data from disk, significantly improving query performance and overall database responsiveness. Computational efficiency focuses on minimizing the time and resources required to perform a task. This can involve optimizing algorithms, leveraging parallel processing, and efficiently managing data access. A scientific simulation model utilizes computational efficiency techniques like parallel processing to reduce the time it takes to run complex simulations, enabling faster research and discovery. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Def my expensive function data return some data too. What does the function sklearn, utils, validation, checks a metric do in scikit-learn? A. Checks if the input matrix is symmetric. B. Checks if the input matrix is non-singular. C. Checks if the input matrix is diagonally dominant. D. All of the above. Correct. The function sklearn, utils, validation, checks a metric explicitly checks if the input matrix is symmetric. It compares elements on opposite sides of the main diagonal AI, judge I. The function sklearn, utils, validation, checks a metric checks if the input matrix is symmetric. It raises a value error if it is not. Incorrect. The function sklearn, utils, validation, checks a metric doesn't check for non-singularity invertibility. This would be a different validation function, potentially related to linear algebra concepts. A. Checks if the input matrix is symmetric. Incorrect. The function sklearn, utils, validation, check symmetric doesn't check for diagonal dominance. This is another specific matrix property related to linear algebra. A. Checks if the input matrix is symmetric. Incorrect. Since options B and C are incorrect, this option is also incorrect. A. Checks if the input matrix is symmetric. A. Checks if the input matrix is symmetric. Symmetric matrix. A matrix where elements on opposite sides of the main diagonal are equal ai, j, I. 1. Symmetric matrix. A matrix where the elements on opposite sides of the main diagonal are equal ai, j, I. Covariance matrix. A symmetric matrix that represents the variances and covariances of multiple variables in a dataset. 2. Covariance matrix. A symmetric matrix that represents the variances and covariances of multiple variables in a dataset. Data validation. The process of ensuring the quality and correctness of data before using it in machine learning models. 3. Data validation. The process of ensuring the quality and correctness of data before using it in machine learning models. Value error. An exception raised in Python when a function encounters an incorrect or invalid input. 4. Value error. An exception raised in Python when a function encounters an incorrect or invalid input. Ensuring data integrity in machine learning models where symmetry is a requirement, e.g. covariance matrices in statistical analysis. 1. Ensuring data integrity in machine learning models where symmetry is a requirement, e.g. covariance matrices in statistical analysis. Validating inputs to algorithms that assume symmetric matrices, preventing unexpected behavior. 2. Validating inputs to algorithms that assume symmetric matrices, preventing unexpected behavior. Debugging and detecting errors in data preprocessing or feature engineering where symmetry is expected. 3. Debugging and detecting errors in data preprocessing or feature engineering where symmetry is expected. Ensuring data quality in applications where symmetric relationships are critical. 4. Ensuring data quality in applications where symmetric relationships are critical. Matrix 1, 2, 3, 2, 4, 5, 3, 5, 6. This matrix is symmetric because elements on opposite sides of the main diagonal are equal, e.g. A1, 2, A2, 1, 2. The function check symmetric would return the matrix without raising an exception. From sklearn, utils, validation import check symmetric. Matrix 1, 2, 3, 2, 4, 5, 3, 5, 6. Check symmetric matrix. What is the primary purpose of the sklearn, utils, validation, columnar 1D function? To ensure that a given input is a 1D array, regardless of its initial shape. To convert a 2D array into a 1D array. To validate and potentially reshape an input to be either a 1D array or a column vector. To check if an input is a column vector. All of the above. To ensure that a given input is a 1D array, regardless of its initial shape. True. The columnar 1D function can indeed flatten multidimensional arrays into a 1D array. Ensuring compatibility with algorithms expecting 1D data. To convert a 2D array into a 1D array. True. As part of its function, it converts 2D arrays into 1D arrays, but it also does other things. To validate and potentially reshape an input to be either a 1D array or a column vector. True. This is the core functionality of columnar 1D. It validates the input and reshapes it if needed to fit the 1D array or column vector expectation. To check if an input is a column vector. True. It's a part of the validation process. The function can determine if the input is already a column vector. All of the above. True. As all of the above choices are true, this is the correct answer. All of the above. 1D array. A one-dimensional array, representing a sequence of values. In Python, 1, 2, 3, 4 is a 1D array representing a sequence of 4 numbers. Column vector. A two-dimensional array with a single column. Often used to represent feature vectors in machine learning. In Python, 1, 2, 3 is a column vector representing 3 features, each with a single value. Data reshaping. The process of rearranging the dimensions of an array, commonly done to prepare data for algorithms. Reshaping a 2 by 3 array into a 6 by 1 column vector using NumPy. Reshape array, 6, 1 in Python. Machine learning algorithms. Computational models that learn patterns from data to make predictions or decisions. Linear regression. Logistic regression. Decision trees. Support vector machines are common machine learning algorithms. Feature vectors. Numerical representations of data points used to describe their characteristics. A feature vector for a house might include its size, number of bedrooms, location, and price. Input data format. The structure and organization of data provided to a machine learning model. Input data for a machine learning model might be in a CSV file, a pandas data frame, or a NumPy array. Training linear regression models. Linear regression algorithms often expect input features to be in a 1D array or a column vector format. Columnar 1D ensures data compatibility. Applying feature scaling techniques. Scaling techniques like standardization or normalization typically operate on 1D arrays or column vectors. Columnar 1D prepares the data for these operations. Using dimensionality reduction algorithms. Many dimensionality reduction techniques, such as principal component analysis (PCA), work on 2D arrays representing feature vectors. Columnar 1D can help ensure the correct input format. Working with decision trees. Decision trees often expect features to be in a 1D array format for splitting nodes. Columnar 1D can be useful in this context. What does the sklearn, utils, validation, hasFit parameter function do? A. Checks if a given estimator has a fit method. B. Checks if a given estimator has a fit parameter in its init method. C. Checks if a given estimator has a fit method and a fit parameter in its init method. This is incorrect. While it's true that estimators typically have a fit method for training, the hasFit parameter function checks for both a fit method and a fit parameter. A. Checks if a given estimator has a fit method. This is also incorrect. The hasFit parameter function checks for the fit parameter within the init method but also ensures that the estimator has a fit method. B. Checks if a given estimator has a fit parameter in its init method. This is the correct answer. The hasFit parameter function verifies that an estimator has both a fit method for training and a fit parameter within its init method, ensuring proper initialization for training. C. Checks if a given estimator has a fit method and a fit parameter in its init method. C. An estimator is a fundamental component of machine learning. It's an algorithm that learns patterns from data and then applies those patterns to make predictions on new data. Think of it as the engine that powers your machine learning model. Let's say you have a dataset of house prices and their features size, location, etc. You want to build a model to predict future house prices. An estimator like linear regression would be used to learn the relationship between these features and prices. Imagine you have a dataset of students' study hours and their corresponding test scores. Using an estimator like linear regression, you can learn the relationship between these variables, represented by a line. The estimator finds the best fitting line that minimizes the errors between predicted scores and actual scores. This line can then be used to predict the scores of future students based on their study hours. The fit method is how you train your estimator. It takes your training data as input and adjusts the estimator's internal parameters to find the best possible representation of the patterns in your data. Using a house price example, the fit method would take your historical house price data and learn the relationship between features, size, location, and prices. This process allows the estimator to learn how those features influence price. The init method is a special method in Python classes. It's like a blueprint for creating objects of that class. It initializes the object's attributes, its properties and characteristics. Let's think about a house price predictor. The init method might initialize attributes like the learning rate, how quickly the estimator learns, the regularization parameter, a way to avoid overfitting, and the type of regression, linear, etc. A fit parameter is specifically used during the training process. It's a value you pass to the fit method to control how the estimator learns from the data. You can think of it as a parameter that directs the training process. In a house price example, a fit parameter might be the size of the training set or the number of iterations, how many times the estimator adjusts its parameters to improve its fit on the data. Creating custom estimators. You can create your own machine learning algorithms. The hasFit parameter function helps ensure that your custom estimators are correctly defined, making them compatible with tools like pipelines. Let's say you develop a new algorithm for predicting house prices. The hasFit parameter function would help you verify that your algorithm has the necessary components, like the fit method and fit parameter, before using it in your pipeline for automated model building. Validating existing estimators. This function can be used to check whether an existing estimator has the right components for fitting a model. This is useful when working with complex pipelines or when you need to ensure that an estimator meets specific requirements. Imagine you are using a complex pipeline with multiple machine learning models. The hasFit parameter function can help you ensure that each estimator in the pipeline is properly set up for training and prediction. Sklearn estimators. The core of Sklearn are its estimators. They represent different machine learning algorithms, like linear regression, decision trees, or support vector machines. You can use Sklearn's linear regression estimator for predicting house prices based on features like size and location. You can also use decision tree classifier for classifying images into different categories. Sklearn pipelines. Pipelines allow you to combine multiple steps in your machine learning workflow into a single object. This simplifies model building and makes it easier to automate your tasks. A pipeline might include data preprocessing steps like scaling or encoding, model selection, training, and prediction, all neatly organized. Sklearn model selection. This part of Sklearn helps you find the best performing model for your task. It provides tools for comparing different algorithms, choosing the optimal parameters, and evaluating model performance. You might use cross-validation techniques from Sklearn to test your model's performance on different subsets of the data and choose the best model for your specific dataset. Sklearn preprocessing. Sklearn offers a wide range of tools for preparing your data for machine learning. This includes scaling, encoding categorical variables, and handling missing data. Before training a model on house price data, you might need to scale numerical features like house size to prevent one feature from dominating others. Sklearn metrics. Sklearn provides a variety of metrics for evaluating your machine learning models. This helps you understand how well your model performs and to compare different model choices. You might use metrics like mean squared error to evaluate your house price prediction model and see how close its predictions are to the actual prices. Sklearn utilities. Utilities are a set of helper functions in Sklearn that streamline common tasks and provide useful tools for working with estimators, pipelines, and data. Sklearn datasets. Sklearn offers a collection of built-in datasets for practicing and testing machine learning algorithms. These datasets are readily available and often used as starting points for learning in experimentation. Object-oriented programming. OOP. OOP is a programming paradigm that revolves around the concept of objects. Objects encapsulate data, attributes, and behavior methods to represent real-world entities. This makes code more modular, reusable, and easier to manage. Python functions. Functions are blocks of reusable code that perform specific tasks. They make your code more organized and efficient by avoiding redundancy. Python classes. Classes are blueprints for creating objects. They define the attributes, data, and methods behavior that an object will have. This allows you to model real-world entities and relationships within your code. Python methods. Methods are functions that belong to a class. They define the actions that an object of that class can perform. Python parameters. Parameters are values that you pass to functions and methods to provide them with information or control their behavior. Python attributes. Attributes are variables that belong to an object. They store the data or properties of the object. Machine learning. The field of machine learning focuses on building algorithms that can learn from data without explicit programming. These algorithms can make predictions, classify data, and automate tasks. Data science. Data science involves using data to extract insights, solve problems, and make informed decisions. It encompasses techniques from machine learning, statistics, and computer science. Python. Python is a popular programming language widely used in machine learning and data science due to its readability, versatility, and extensive libraries. Which of the following statements about Sklearn meta estimators is true? A. They allow for combining multiple estimators into one. B. They handle data preprocessing and feature engineering. C. They can be used for model selection and hyperparameter tuning. D. All of the above. Correct meta estimators are designed to combine multiple estimators. For example, the random forest classifier combines multiple decision trees to create a more robust and accurate model. Concept explanation. LTBRGTLT font style font size 14px quotient meta estimators provide a framework to combine multiple estimators or functionalities. LT font GT. Correct meta estimators can wrap other estimators for data preprocessing and feature engineering. For example, the pipeline class allows you to chain together different preprocessing steps and a final estimator. Concept explanation. LTBRGTLT font style font size 14px GT. They can wrap estimators for preprocessing, feature selection, and transformation. LT font GT. Correct meta estimators can be used for tasks like model selection and hyperparameter optimization. Grid search CV and randomized search CV are meta estimators that automate this process by trying different combinations of parameters and evaluating their performance. Concept explanation. LTBRGTLT font style font size 14px GT. They provide mechanisms for iterative model fitting, parameter tuning, and model selection. LT font GT. Correct since A, B, and C are all true. D is also correct. Answer D. D. All of the above. Ensemble methods. Combining multiple estimators to improve prediction accuracy and robustness. Examples include random forests, gradient boosting, and bagging. Pipelines. Automating data transformation and model training into sequential steps. A pipeline can be used to pre-process data, e.g., scaling features, select features, and then train a model. Hyperparameter optimization. Finding the best set of hyperparameters for a given model. Techniques like grid search and random search help in finding optimal hyperparameters. Model selection. Choosing the best model for a given problem. Using meta estimators for model selection. E.g., comparing performance of different regression models on a dataset. Cross-validation. Evaluating model performance using different subsets of data. K-fold cross-validation is a popular method for evaluating model performance on unseen data. Feature engineering. Transforming raw data into features relevant for modeling. Examples include creating new features based on existing ones. Using domain knowledge to create relevant features. How can you conditionally include a meta estimator based on the availability of certain features in your data using sklearn's utils? A. Using the available if parameter in the make pipeline constructor. B. Employing the make union function with a conditional statement. C. Utilizing the available if parameter within a custom column transformer. D. None of the above. C. Utilizing the available if parameter within a custom column transformer. A. Using the available if parameter in the make pipeline constructor. Incorrect. The make pipeline constructor in sklearn does not have an available if parameter. Make pipeline is used for creating sequential pipelines where each estimator's output is fed as input to the next estimator. It doesn't offer conditional inclusion of estimators based on features. A. Using the available if parameter in the make pipeline constructor. B. Employing the make union function with a conditional statement. Incorrect. While make union allows combining multiple estimators into a single estimator, it doesn't have the ability to conditionally include estimators based on features. It simply combines the predictions of the individual estimators. B. Employing the make union function with a conditional statement. C. Utilizing the available if parameter within a custom column transformer. Correct. Sklearn's column transformer is specifically designed to handle transformations on different columns of your data. The available if parameter lets you specify conditions for including or excluding transformers based on feature availability. C. Utilizing the available if parameter within a custom column transformer. D. None of the above. Incorrect. Choice C is the correct way to conditionally include a meta estimator based on feature availability. D. None of the above. Suppose you have a dataset with both numerical and categorical features. You want to apply a standard scalar to the numerical columns and a one-hot encoder to the categorical columns. However, you only want to use the standard scalar if certain numerical features are present in the data. Available if lets you conditionally include the scalar based on the availability of those specific columns. Imagine you have a dataset with columns like age, income, gender, and education. You want to standardize the numerical columns age and income, but only if both columns are present. You can use available if within column transformer to include the standard scalar only if both age and income columns exist in the dataset. Method estimators are high-level estimators in sklearn that build upon existing estimators to create more complex pipelines. They combine and manage operations of different underlying estimators. Imagine you have a machine learning task that involves both feature engineering and model selection. A method estimator like pipeline helps chain together these steps, allowing you to perform pre-processing, feature transformations, and model training within a single object. A specialized method estimator in sklearn that applies different transformers to specific subsets of columns in your data. This is particularly useful for handling data with diverse feature types, e.g., numerical, categorical. Imagine you have a dataset with age, income, gender, and education columns. You want to standardize age and income using standard scalar and one-hot encode gender and education. Using one-hot encoder, column transformer lets you define these transformations for specific sets of columns. A parameter available within the column transformer that allows you to specify a condition for including a particular transformer in the transformation pipeline. The condition is typically based on the presence or absence of specific columns in your data. Suppose you want to apply standard scalar to numerical columns but only if age is present. You can use available IFAGE within the column transformer definition. LT font style font size 16px GT. You are building a machine learning model to detect fraudulent transactions in a financial dataset. The dataset is highly imbalanced, with a significantly higher number of legitimate transactions than fraudulent ones. Which of the following techniques can you use to address this class imbalance problem by adjusting the weights given to different classes during model training? LT font GT. A. LT font style font size 14px oversampling LT font TGT. B. LT font style font size 14px undersampling LT font TGT. C. LT font style font size 14px class weights LT font TGT. D. LT font style font size 14px all of the above. LT font GT. LT font style font size 16px GT1. Oversampling. This technique involves creating copies of instances from the minority class fraudulent transactions in our case to balance the dataset. Libraries like sklearn provide techniques like smooth synthetic minority oversampling technique to generate synthetic minority class instances. LT font GT. True. LT font style font size 16px GT2. Undersampling. Conversely, undersampling reduces the number of instances from the majority class legitimate transactions to create a more balanced dataset. Techniques like random undersampling remove instances randomly, while more sophisticated methods aim to preserve valuable information from the majority class. LT font GT. True. LT font style font size 16px GT3. Class weights. This method directly assigns weights to different classes during model training. The weight assigned to each class is inversely proportional to its frequency in the dataset. By assigning higher weights to the minority class, the model is encouraged to focus more on correctly predicting those instances. LT font GT. True. LT font style font size 16px all three techniques are effective in handling class imbalance. Let's explore how they work in practice. LT font GT. True. D. LT font style font size 14 px quotient all of the above LT font GT. LT font style font size 14 px GT1. Class imbalance LT font GT. In fraud detection, a dataset may have many more legitimate transactions than fraudulent ones. This imbalance can mislead the model into favoring predictions of the majority class legitimate in ignoring the minority class fraudulent. Imagine you have a dataset of 1000 transactions with only 10 fraudulent transactions. A model trained on this data might become biased towards predicting legitimate transactions, even if there are subtle signs of fraud. LT font style font size 14 px GT2. Precision, recall, F1's called font TGT. These metrics are crucial for evaluating models dealing with class imbalance. Precision measures the accuracy of positive predictions, while recall measures the model's ability to identify all positive instances. F1 score balances both precision and recall. In fraud detection, a high-precision model would correctly identify most flagged transactions as fraudulent, while a high-recall model would identify almost all fraudulent transactions, even if it might falsely flag some legitimate transactions. LT font style font size 14 px GT3. ROC AUC LT font GT. ROC AUC is a measure of the model's ability to discriminate between classes. It's especially useful in imbalanced datasets because it considers all possible thresholds for classification. A high ROC AUC score indicates that the model can effectively distinguish between legitimate and fraudulent transactions across various threshold levels. LT font style font size 14 px GT4. Model evaluation metrics LT font TGT. Choosing appropriate evaluation metrics is critical when dealing with class imbalance. Metrics like precision, recall, F1 score, and ROC AUC provide a more nuanced picture than overall accuracy in these scenarios. Instead of relying solely on accuracy, it's essential to analyze precision, recall, and F1 score to understand the model's performance in identifying fraudulent transactions. LT font style font size 14 px GT5. Machine learning models e.g. logistic regression, decision trees LT font TGT. Various machine learning algorithms can be employed for fraud detection, each with its strengths and weaknesses. Logistic regression is often used for binary classification, while decision trees can handle complex relationships in the data. A logistic regression model could be trained to predict the probability of a transaction being fraudulent based on factors like transaction amount, location, and user history. LT font style font size 14 px GT6. Data preprocessing LT font TGT. Before applying any class imbalance techniques, it's vital to preprocess the data. This involves handling missing values, cleaning outliers, and potentially transforming features to improve the model's performance. Feature engineering can be used to create new features that capture potential fraud patterns, like the difference between the transaction amount and the user's average transaction amount. What is the purpose of font color 0000FF sklearn, utils, class weight font function in machine learning? To calculate the weight of each class based on the number of samples in each class. To determine the importance of each feature in the dataset. To standardize the features in the dataset. To perform dimensionality reduction on the dataset. All of the above. To calculate the weight of each class based on the number of samples in each class. True. The font color 0000FF sklearn, utils, class weight font function is primarily used to address class Imbalance problems in machine learning. It computes the weight of each class based on the number of samples present in each class, to determine the importance of each feature in the dataset. False. Determining feature importance is usually done through techniques like feature selection or feature importance scores from models like random forest, to standardize the features in the dataset. False. Feature standardization is a data preprocessing technique, usually achieved using functions like standard scalar or min-max scalar from sklearn preprocessing, to perform dimensionality reduction on the dataset. False. Dimensionality reduction is a different technique used to reduce the number of features, often using methods like PCA principal component analysis or ELDA linear discriminant analysis. All of the above. False. Only option A is correct. Options B, C, and D represent different concepts in machine learning, not related to class weighing. A. Class imbalance. A situation in a dataset where the number of samples in different classes is significantly uneven. Fraud detection. Fraudulent transactions are often a small percentage of all transactions. Medical diagnosis. Rare diseases have fewer samples compared to common ones. Spam filtering. Spam emails are typically much less than legitimate emails. Customer churn prediction. Customers who churn are a smaller subset of the overall customer base. Imagine a dataset with 1000 samples, 900 belonging to class A and 100 to class B. This represents a class imbalance, where class B is underrepresented. Overfitting. A model that performs well on the training data but poorly on unseen data. A spam filter trained on a dataset with only emails from one specific spammer might be highly accurate for that spammer's emails but fail to recognize other spammers' emails. Let's say a model achieves 95 accuracy on the training set but only 70 on a new test set. This indicates overfitting, where the model has memorized the training data too well. Underfitting. A model that fails to learn the underlying patterns in the data, leading to poor performance on both training and unseen data. A model trying to predict house prices based only on the number of bedrooms might underfit because important factors like location, size, and amenities are ignored. If a model consistently achieves low accuracy, e.g., 55 on both training and test sets, it suggests underfitting. Cost-sensitive learning. A technique that assigns different costs to different types of errors during model training, often used to address class imbalance. In medical diagnosis, misclassifying a patient with a serious disease as healthy can have much higher consequences than misclassifying a healthy patient as having the disease. In fraud detection, incorrectly flagging a legitimate transaction as fraudulent might inconvenience the customer, but a false negative missing a fraudulent transaction is far more costly. Imagine a model predicting whether a customer will purchase a product. A false positive predicting a purchase when none occurs might incur a small cost from marketing expenses. However, a false negative failing to predict a purchase that would have occurred could lead to lost revenue. Sampling techniques. Methods used to modify the dataset to address class imbalance by either undersampling the majority class or oversampling the minority class. Undersampling. In a fraud detection dataset, we could randomly remove some legitimate transactions to balance the classes. Oversampling. In a medical dataset, we could duplicate the samples of rare diseases to increase their representation. Consider a dataset with 900 samples of class A and 100 of class B. Undersampling would reduce the A samples to 100, while oversampling would create copies of the B samples to reach 900. Model evaluation metrics. Metrics like precision, recall, F1 score, and AUC are crucial for evaluating the performance of models trained on imbalanced datasets. Precision measuring the proportion of correctly predicted positive cases among all predicted positive cases. Recall measuring the proportion of correctly predicted positive cases among all actual positive cases. F1 score a harmonic mean of precision and recall, providing a balanced measure. AUC area under the curve AUC for the receiver operating characteristic ROC curve, indicating the model's ability to distinguish between classes. A model with 90 accuracy might seem good, but if it misclassifies all positive cases, its precision and recall would be 0. A better metric like F1 score would highlight this issue. You have an imbalanced dataset with 90 Class A instances and 10 Class B instances. You are using a classification model in sklearn. What would be the most appropriate approach to handle this class imbalance using sklearn's class weight parameter? This question explores how to address class imbalance in a dataset using the class weight parameter. In sklearn's classification models, it highlights a common problem in machine learning where one class significantly outnumbers the other. Assign a higher weight to Class B instances than Class A instances to balance the contribution of each class during model training. A. Assign a higher weight to Class B instances than Class A instances to balance the contribution of each class during model training. This choice correctly addresses the imbalance by increasing the influence of the minority Class B during training, making it more likely that the model will learn to correctly classify minority class instances. This strategy aims to balance the contribution of each class to the model's learning process. True. Assign a lower weight to Class A instances than Class B instances to make the model focus more on the minority class Class B. B. Assign a lower weight to Class A instances than Class B instances to make the model focus more on the minority class Class B. This option also works to balance the class distribution by reducing the impact of the majority Class A on the model's training. This approach makes the model more attentive to the minority class by reducing the influence of a majority class. True. Assign equal weights to both classes to ensure all data points contribute equally to the model training. C. Assign equal weights to both classes to ensure all data points contribute equally to the model training. While assigning equal weights is a common practice for balanced datasets, in an imbalanced dataset, this approach could lead to the model primarily focusing on the majority class, potentially neglecting the minority class. False. All of the above options are valid approaches for handling class imbalance with class weight. D. All of the above options are valid approaches for handling class imbalance with class weight. This is the correct answer because all the preceding options represent valid strategies for addressing class imbalance using the class weight parameter. The choice of strategy depends on the specific characteristics of the dataset and the desired outcome. True. D. All of the above options are valid approaches for handling class imbalance with class weight. Class imbalance. When one class significantly outnumbers the others in a dataset, resulting in a model that might be biased towards the majority class. For example, in fraud detection, fraudulent transactions are usually much rarer than legitimate transactions. Consider a dataset of loan applications where 95 of applications are approved and 5 are rejected. If a model is trained on this dataset without addressing the imbalance, it may become very good at predicting approved loans but struggle with predicting rejected loans. Class weights. A mechanism to adjust the influence of different classes during model training. Higher weights for minority classes make them more important. This helps ensure the model learns from the minority class better. By assigning higher weights to rejected loan applications, the model would be incentivized to learn from the minority class, leading to better predictions for both approved and rejected applications. sklearn, utils, class weight, compute class weight. A function in scikit-learn to calculate class weights based on different strategies. It helps determine weights for each class based on the class distribution. Use cases. Class imbalance is a common challenge in various machine learning applications where one class is significantly underrepresented. Fraud detection. Fraudulent transactions are rare. Medical diagnosis. Certain diseases are less common. Anomaly detection. Anomalies are infrequent events or some common use cases where class imbalance is prevalent. Class weight parameter. A parameter in scikit-learn classifiers that allows you to specify weights for each class, enabling you to control the influence of different classes during model training. Which of the following statements accurately describes the purpose of sklearn, utils, class weight, computes ample weight function in scikit-learn? It calculates the weights for each sample based on the inverse frequency of the class to address class imbalance. It assigns equal weights to all samples, regardless of the class distribution. It determines the optimal learning rate for a given classification model. It calculates the weights for each sample based on the frequency of the class to address class imbalance. All of the above. True. The LTBGT sklearn, utils, class weight, computes ample weight. LTBGT function assigns weights to each sample in a dataset, aiming to counter class imbalance. It accomplishes this by assigning higher weights to instances belonging to underrepresented classes and lower weights to instances from overrepresented classes. LT font style font size 14 px the LTBGT sklearn, utils, class weight, computes ample weight. LTBGT function assigns weights to each sample in a dataset, aiming to counter class imbalance. It accomplishes this by assigning higher weights to instances belonging to underrepresented classes and lower weights to instances from overrepresented classes. LT font GT. False. This statement is incorrect. The LTBGT sklearn, utils, class weight, computes ample weight. LTBGT function is specifically designed to address class imbalance by adjusting weights based on the class frequency. LT font style font size 14 px the LTBGT sklearn, utils, class weight, computes ample weight. LTBGT function assigns weights to each sample in a dataset, aiming to counter class imbalance. It accomplishes this by assigning higher weights to instances belonging to underrepresented classes and lower weights to instances from overrepresented classes. LT font GT. False. This statement is incorrect. The LTBGT sklearn, utils, class weight, computes ample weight. LTBGT function focuses on adjusting sample weights, not determining learning rates. LT font style font size 14 px the LTBGT sklearn, utils, class weight, computes ample weight. LTBGT function assigns weights to each sample in a dataset, aiming to counter class imbalance. It accomplishes this by assigning higher weights to instances belonging to underrepresented classes and lower weights to instances from overrepresented classes. LT font GT. False. This statement is incorrect. The LTBGT sklearn, utils, class weight, computes ample weight. LTBGT function uses the LTBGT inverse LTBGT Frequency of the class, not the frequency itself. To calculate weights, LT font style quote font size 14px quotient the LTBGT sklearn, utils, class weight, computes ample weight LTBGT. Function assigns weights to each sample in a dataset, aiming to counter class imbalance. It accomplishes this by assigning higher weights to instances belonging to underrepresented classes and lower weights to instances from overrepresented classes. LT font GT. False. This statement is incorrect. Only option A is a true statement about the purpose of the function. Options B, C, and D are incorrect. LT font style quote font size 14px quotient the LTBGT sklearn, utils, class weight, computes ample weight LTBGT. Function assigns weights to each sample in a dataset, aiming to counter class imbalance. It accomplishes this by assigning higher weights to instances belonging to underrepresented classes and lower weights to instances from overrepresented classes. LT font GT. A. It calculates the weights for each sample based on the inverse frequency of the class to address class imbalance. Class imbalance occurs when the distribution of classes in a dataset is uneven. Some classes have significantly more instances than others. Fraud detection. Fraudulent transactions are often a minority compared to legitimate transactions. Medical diagnosis. Certain diseases are rare, resulting in imbalanced datasets. Class weights are numerical values assigned to each class in a dataset. They indicate the relative importance of each class during training. Higher weights signify greater importance. Fraud detection. Fraudulent transactions are often a minority compared to legitimate transactions. Medical diagnosis. Certain diseases are rare, resulting in imbalanced datasets. Sample weights are numerical values assigned to each instance in a dataset. They indicate the relative importance of each instance during training. Higher weights signify greater importance. Fraud detection. Fraudulent transactions are often a minority compared to legitimate transactions. Medical diagnosis. Certain diseases are rare, resulting in imbalanced datasets. Inverse frequency weighing assigns weights to samples based on the inverse of the class frequency. Rarer classes receive higher weights to balance their underrepresentation. Fraud detection. Fraudulent transactions are often a minority compared to legitimate transactions. Medical diagnosis. Certain diseases are rare, resulting in imbalanced datasets. This function in sklearn calculates sample weights based on the class distribution. It is often used to address class imbalance in machine learning tasks. Fraud detection. Fraudulent transactions are often a minority compared to legitimate transactions. Medical diagnosis. Certain diseases are rare, resulting in imbalanced datasets. 1, 2, 3, 4, 5, 6, 7, 8. In this example, class A has 5 instances, while class B has 3 instances. Class imbalance exists because class A is more frequent than class B. The computes ample weight function would assign higher weights to instances of class B to balance their underrepresentation. For instance, class B instances might receive a weight of 2, while class A instances might receive a weight of 1. You are building a model to predict the type of fruit based on its features: color, shape, size. What function from sklearn, utils can you use to efficiently convert the categorical fruit names, e.g. apple, banana, orange, into numerical labels for training a multiclass classification model? A. Sklearn, utils, encode categorical. B. Sklearn, utils, label encoder. C. Sklearn, utils, one hot encoder. D. All of the above. A. sklearn, utils, encode categorical. Incorrect. There's no function named sklearn, utils, encode categorical in scikit-learn. sklearn, utils primarily handles utility functions for model development. False. A. LT font style quote font size 14 px quote sklearn, utils, encode categorical 20 gt. B. sklearn, utils, label encoder. Correct. sklearn, utils, label encoder is a class used for label encoding. It assigns unique integer labels to categorical features. For example, apple might become 0, banana 1, and orange 2. This numerical representation enables machine learning models to process the data. True. B. LT font style quote font size 14 px quote sklearn, utils, label encoder LT font egt. C. sklearn, utils, one-hot encoder. Correct. sklearn, utils, one-hot encoder is a class used for one-hot encoding. It transforms categorical features into a binary matrix. For example, apple would be represented as 1, 0, 0, banana as 0, 1, 0, and orange as 0, 0, 1. This encoding method ensures that the model doesn't interpret the order of categories as having inherent significance. True. C. LT font style quote font size 14 px quote sklearn, utils, one-hot encoder LT font egt. D. All of the above. Correct. All the above functions can be used for this task. Though sklearn, utils, encode categorical does not exist, label encoder and one-hot encoder are both powerful techniques for handling categorical features in machine learning models. And the choice between them often depends on the specific requirements of your model and data. True. D. LT font style quote font size 14 px quotient all of the above LT font gt. D. All of the above. Multiclass classification. A type of classification problem where the target variable can belong to one of multiple categories. For example, predicting the type of fruit apple, banana, orange based on features like color, shape, and size. Image classification identifying different objects in images, like cars, bicycles, or people. Sentiment analysis categorizing text as positive, negative, or neutral. Medical diagnosis predicting the presence or absence of specific diseases. Customer churn prediction identifying customers likely to stop using a service. Label encoding, a technique for converting categorical features into numerical labels. Each distinct category is assigned a unique integer. This is useful for models that require numerical input. Predicting customer purchase behavior based on their buying history. Identifying the most popular products in an online store. Segmenting customers based on their demographics. Predicting customer satisfaction based on feedback data. One-hot encoding, a technique that creates binary features for each category. A 1 indicates the presence of the category, and a 0 indicates its absence. This encoding prevents the model from assigning ordinal relationships to categories. Predicting the likelihood of a customer buying a specific product. Classifying text documents into different topics. Detecting fraudulent transactions. Predicting the success rate of marketing campaigns. sklearn, utils, label encoder. A scikit-learn class used for label encoding. Converting categorical labels into numerical labels. It provides a simple and efficient method for handling categorical features in machine learning models. Encoding categorical features like gender, profession, or city in a customer dataset. Converting categorical features in image classification datasets. Encoding text data before applying natural language processing techniques. Preprocessing data for time series analysis. sklearn, utils, one-hot encoder. A scikit-learn class used for one-hot encoding. Transforming categorical features into a binary matrix. It's particularly useful for multi-class classification problems where categorical features need to be represented as numerical inputs. Encoding categorical features in a customer dataset for predicting churn. Converting categorical features in a medical dataset for disease prediction. Encoding categorical features in a marketing dataset for campaign optimization. Preprocessing data for fraud detection models. Consider a dataset with the fruit column. Fruit encoded. Apple 0, banana 1, orange 2, apple 0, banana 1. This represents label encoding. Each unique fruit gets a unique integer assigned. The same dataset with one hot encoding would look like this. Fruit apple banana orange. Apple 1 0. Banana 010, orange 001, apple 100, banana 010. Each fruit is represented as a binary vector, with a 1 for its category and 0 for others. What does sklearn, utils, multi-class, type of targetee return for multi-class classification with multiple labels per instance? A. Multi-class. B. Multi-label indicator. C. Binary. D. All of the above. True. In multi-class classification with multiple labels per instance, the target data can be represented as simple lists of labels, which is considered multi-class by sklearn, utils, multi-class, type of target. True. Another common representation of multi-label data is using one-hot encoded arrays, where each column corresponds to a label and a 1 indicates the presence of that label. This is referred to as multi-label indicator by the function. True. Multi-label data can also be represented as binary arrays where each column signifies a label, and a 1 indicates the presence and a 0 indicates the absence of that label. This is identified as binary by the function. True. Since multi-label data can be represented in multiple ways, including multi-class, multi-label indicator, and binary, the function correctly returns all of the above. D. All of the above. Multi-class classification. A classification task where the target variable can take on more than 2 distinct values. Classifying images of different types of animals: cats, dogs, birds. Multi-label classification. A classification task where each instance can be assigned multiple labels simultaneously. Tagging a document with multiple topics, e.g., technology, science, business. sklearn, utils, multi-class, type of target. A function within scikit-learn that analyzes the target data and determines the type of target based on its structure and values. Determining the appropriate machine learning algorithm for a multi-class classification task. Dog, cat, bird, dog, cat, dog, bird. Multi-class. In this example, each instance row can have multiple labels animals. This is a multi-label classification task. The target data can be represented as simple lists of labels, making it multi-class, or as one-hot encoded arrays, making it multi-label indicator, or as binary arrays, making it binary. How can you determine if a scikit-learn dataset is multi-label using the multi-label function from the utils multi-class module? A. By passing the target variable y directly to multilabelly. B. By passing the dataset x to isMultilabels. C. by passing the target variable y as an argument to is multilabel. D. None of the above. This is the correct method. The is multilabel function specifically analyzes the target variable y to determine if it represents a multilabel dataset. It checks the structure and data within y to identify whether each sample can belong to multiple classes. True. Understanding multilabel and multiclass classification. This is incorrect. The is multilabel function is designed to examine the target variable y to determine the nature of the classification task. The dataset X contains the features, and it's not relevant in determining multilabel classification. False. Understanding multilabel and multiclass classification. This statement is also correct. It emphasizes the same concept as choice A. The is multilabel function expects the target variable as its input to assess whether the dataset is multilabel or not. True. Understanding multilabel and multiclass classification. This choice is incorrect, as explained in choices A and C. Passing the target variable y to is multilabel is the correct way to determine if the dataset is multilabel. False. Understanding multilabel and multiclass classification. A. By passing the target variable y directly to is multilabelly. In multiclass classification, the target variable has more than two classes, but each sample belongs to only one class. This means there are multiple categories, and each data point is classified into a single category. Imagine classifying different types of fruits: apple, banana, and orange. Each fruit belongs to only one category. This is a multiclass classification problem because there are multiple classes fruit types. Multiclass classification. In multilabel classification, each sample can belong to multiple classes simultaneously. This means a single data point can be assigned to multiple categories. Think of classifying images with multiple keywords. An image might have tags landscape, sunset, and mountain all at once. This is multilabel classification because each image can have multiple labels. Multilabel classification. This function in sklearn is a utility to identify whether a dataset is multilabel or not. It analyzes the target variable y to determine if each data point can have multiple labels. It returns true if the dataset is multilabel and false otherwise. This function helps developers understand the nature of their dataset and select appropriate machine learning algorithms accordingly. Sklearn's is multilabel function. In machine learning, the target variable y represents the variable we are trying to predict. It's the output variable that the model learns to map from the input features. In the context of classification, the target variable usually contains the class labels for each data point. Target variable y. What does the sklearn, utils, multiclass, unique labels function return when applied to a multiclass dataset with labels like 1, 2, 3, 1, 2, 4, A1, 2, 3, 4, B1, 2, 3, C4, 3, 2, 1, D. All of the above. The unique labels function returns a sorted array of unique labels present in the dataset. So, the correct answer is true. This choice is correct. The unique labels function identifies all the distinct labels in the input, which are 1, 2, 3, and 4, and returns them in sorted order. False. This choice is incorrect because it misses the label 4, which is present in the input dataset. The unique labels function aims to capture all unique labels. False. This choice is incorrect. While it contains all the unique labels, it presents them in reverse order. The unique labels function returns labels in ascending order. False. This choice is incorrect because only option A is correct. Options B and C are incorrect as explained above. A1, 2, 3, 4. Related concepts. Multiclass classification. In multiclass classification, there are more than two classes to predict. For example, classifying images into different animal types cat, dog, bird is a multiclass classification problem. Data preprocessing. Data preprocessing involves transforming raw data into a suitable format for machine learning. This can include steps like handling missing values, scaling features, and encoding categorical variables. Identifying unique labels is a crucial part of preprocessing for multi-class problems. Sklearn utils. Sklearn utils provides various utility functions that simplify common tasks in machine learning. These functions help with data manipulation, model selection, and evaluation, making the workflow more efficient. Unique labels extraction. Extracting unique labels is essential for understanding the different categories present in a dataset. This information is useful for various tasks like model training, evaluation, and interpreting results. Unique labels function. The unique labels function is a tool in sklearn utils specifically designed for extracting unique labels from a dataset. It returns a sorted array of unique labels, making it easy to understand the classification task at hand. Dataset analysis. Analyzing a dataset involves understanding its characteristics, such as the distribution of features, relationships between variables, and the presence of outliers. Knowing unique labels helps to analyze the distribution of classes in a multi-class dataset. Model evaluation. Model evaluation assesses the performance of a machine learning model. Knowing unique labels is crucial for evaluating multi-class models, as specific metrics like accuracy and precision are calculated based on the number of classes. Model selection. Model selection involves choosing the best model for a given task. Understanding the unique labels helps in selecting an appropriate model, considering the complexity of the classification problem. Hyperparameter tuning. Hyperparameter tuning optimizes the performance of a model by adjusting its settings. Knowing unique labels can influence hyperparameter choices, such as the number of classes used in the model. Model deployment. Model deployment involves making a trained model available for use. Understanding unique labels ensures that the deployed model can correctly handle the range of classes in the real-world data it encounters. Use cases. Identifying distinct classes in a multi-class dataset. Imagine you have a dataset of customer reviews labeled with sentiment positive, negative, neutral. Using unique labels helps you quickly determine that you are dealing with a three-class classification problem. Preparing data for multi-class classification models. Before training a model for image classification, e.g., recognizing different types of flowers, unique labels helps to determine the number of flower categories and ensure consistent label representation for model input. Ensuring consistency in model evaluation metrics. When evaluating a model for text classification, unique labels guarantees that the evaluation metrics like precision and recall are calculated correctly across all the distinct categories in the dataset. Defining the range of labels for model predictions. In a spam detection model, unique labels helps to identify the different spam types: phishing, malware, advertising that the model should be able to classify. This ensures that the model's predictions are consistent with the expected output range. Debugging classification errors by identifying missing labels. If a model misclassifies a specific type of product in an e-commerce recommendation system, Unique labels can help to identify whether the model has not been trained on that particular product. Category: highlighting a potential training data issue. Building custom classification systems that need label management. Developing a custom system for classifying customer feedback based on different keywords and phrases requires a method for managing and extracting unique labels. Unique labels provides a robust solution for this. Streamlining data analysis workflows with label manipulation. In a medical diagnosis system, unique labels helps to organize and manage the different disease labels. Streamlining data analysis for identifying patterns and trends related to diagnosis and treatment. Improving model interpretability by understanding class relationships. When analyzing customer behavior patterns based on product preferences, unique labels helps to understand the distinct categories of products and their relationships, contributing to a more interpretable model that can explain why customers make specific choices. Code example: Python. From sklearn, utils, multi-class import unique labels. Labels 1, 2, 3, 1, 2, 4. Unique labels result unique labels labels. Print unique labels result. Output 1, 2, 3, 4. What is the primary purpose of XSmart module within sklearn? A. Provides optimized mathematical operations for numerical linear algebra calculations. B. Implements advanced data preprocessing techniques like feature scaling and dimensionality reduction. C. Facilitates the creation and manipulation of sparse matrices, enhancing efficiency for large datasets. D. All of the above. True. The XSmart module in sklearn focuses on providing efficient and optimized implementations of common linear algebra operations like matrix multiplication, singular value decomposition (SVD), and eigenvalue decomposition. This optimization is crucial for improving the performance of algorithms, especially when dealing with large datasets. For example, performing matrix multiplication using optimized algorithms can significantly reduce execution time, making algorithms more efficient. Optimized mathematical operations. A. XSmart provides optimized versions of common linear algebra operations like matrix multiplication, singular value decomposition (SVD), and eigenvalue decomposition. This optimization is crucial for improving the performance of algorithms that heavily rely on these calculations, especially when dealing with large datasets. True. While XSmart doesn't directly implement these preprocessing techniques, it plays a crucial role in enhancing their performance. The optimized linear algebra operations within XSmart can significantly accelerate data preprocessing methods. For instance, feature scaling techniques like standardization often involve matrix multiplication and other linear algebra operations, which can be made much faster using XSmart's optimized algorithms. Advanced preprocessing. B. XSmart doesn't directly implement preprocessing techniques. This aspect is handled by dedicated modules within sklearn, like preprocessing and decomposition. However, the optimized operations in XSmart play a crucial role in enhancing the performance of these preprocessing methods. True. The XSmart module includes functions designed to handle sparse matrices effectively. Sparse matrices are highly efficient representations of datasets with many zero values, which are common in many real-world scenarios. XSmart's optimized operations on sparse matrices enable efficient processing of large datasets without the burden of handling unnecessary zeros. Sparse matrix handling. C. XSmart includes functions specifically designed for working with sparse matrices. Sparse matrices are efficient representations of datasets with many zero values. Operations on sparse matrices are optimized within sklearn, enabling efficient processing of large datasets with sparse representations. True. The sklearn module in sklearn encompasses all of the above functions. It provides optimized linear algebra operations, contributes to the efficiency of preprocessing techniques, and facilitates efficient sparse matrix manipulation. Therefore, sklearn is a versatile module designed to enhance the performance of various machine learning tasks. D. All of the above. Recommender systems. Xmath's optimized matrix factorization algorithms are essential for collaborative filtering. Techniques used in recommendation systems. The sparse matrix handling capabilities are also crucial for dealing with user item interaction data. Natural language processing (NLP). Xmath can be used to accelerate NLP tasks involving large text corpora. It helps in efficiently performing calculations on text representations, like term frequency inverse document frequency TF-IDF matrices, which are often sparse. Computer vision. Image processing and computer vision tasks often involve large matrices of pixel data. Xmath's optimized operations can accelerate image transformations, feature extraction, and dimensionality reduction techniques, leading to faster image analysis. Linear algebra. Understanding concepts like matrices, vectors, eigenvalues, and singular values is crucial for grasping the purpose of Xmath. Sparse matrices. Xmath's focus on sparse matrices is crucial for handling data with many zero values, which is common in many real-world datasets. Computational efficiency. Xmath emphasizes optimized algorithms to speed up computations, especially in machine learning models. Scikit-learn architecture. Understanding how Xmath fits into scikit-learn's overall architecture is important for leveraging its capabilities. What is the purpose of the sklearn, utils, Xmath, safesparse function in scikit-learn? A. To perform dot product operations between dense and sparse matrices, ensuring numerical stability and handling potential overflow issues. B. To efficiently perform matrix multiplications between two sparse matrices, optimizing for memory usage and computational speed. C. To calculate the dot product of a sparse matrix with a dense vector, enabling efficient feature transformations in machine learning models. D. All of the above. This choice is correct. The safesparse function is designed to handle dot product operations between dense and sparse matrices, which is a common scenario in machine learning involving sparse data. The safesparse function in scikit-learn is designed to perform dot product operations between dense and sparse matrices. This choice is partially correct. While the function is optimized for efficiency, it's primarily focused on handling dot products between dense and sparse matrices. It can be used for multiplying two sparse matrices but might not be the most efficient option for this specific use case. It handles sparse matrices represented using formats like CSR compressed sparse row or CSC compressed sparse column. The function is optimized for efficiency, handling sparse matrices in a way that minimizes memory usage and computational time. This choice is also partially correct. The safesparse function can be used to calculate the dot product of a sparse matrix with a dense vector, but this is just a specific application of its general functionality, which extends to handling dot products between dense and sparse matrices. It handles sparse matrices represented using formats like CSR compressed sparse row or CSC compressed sparse column. This choice is correct. Based on the explanations above, the safesparse function covers all the functionalities mentioned in choices A, B, and C. The safesparse function in sklearn is designed to handle dot product operations between dense and sparse matrices efficiently and stably. It's a versatile tool for various scenarios involving sparse data. D. Sparse matrices. Sparse matrices are matrices where a majority of elements are zero. They are efficient for storing and processing data with many zero values. Common in text processing, collaborative filtering, etc. Sparse matrices, CSR and CSC formats. CSR compressed sparse row and CSC compressed sparse column are efficient storage formats for sparse matrices. They store only the non-zero elements and their indices, significantly reducing memory usage. CSR and CSC formats. Numerical stability. Numerical stability refers to the ability of an algorithm to produce accurate results despite rounding errors or potential overflow issues in calculations. The safesparse function ensures numerical stability by implementing strategies to prevent these problems. Numerical stability. Computational efficiency. Computational efficiency refers to the speed and memory usage of an algorithm. The safesparse function is optimized for efficiency, using the sparse matrix formats and specialized algorithms to minimize computational time and memory requirements. Computational efficiency. Machine learning models. Machine learning models are algorithms that learn patterns from data. Sparse data often arises in machine learning applications, and functions like safesparse are crucial for handling these scenarios efficiently. Machine learning models. Linear regression. Linear regression is a statistical method for predicting a target variable based on a linear relationship with one or more predictor variables. Sparse data can be used in linear regression models, requiring efficient handling of dot products between dense and sparse matrices. Linear regression. Collaborative filtering. Collaborative filtering is a technique used in recommendation systems to predict user preferences based on the ratings or preferences of similar users. Sparse matrices are often used to represent user item ratings or preferences, making functions like safesparse relevant for these applications. Collaborative filtering. Recommendation systems. Recommendation systems aim to suggest items or content that users are likely to be interested in. Collaborative filtering, which often utilizes sparse data, is a key technique in recommendation systems. Recommendation systems. Suppose you have a sparse matrix representing movie ratings from users, and you want to calculate the similarity between users based on their ratings. You can use the safesparse function to efficiently perform the dot product between the sparse user rating matrix and its transpose, resulting in a matrix that captures the similarity between users. 5, 0, 3, 0, 0, 0, 4, 0, 0, 2, 1, 0, 2, 0, 0, 0, 0, 0, 5, 4, 0, 0, 0, 3, 0, 5, 0, 1, 0, 0, 0, 4, 0, 0, 0, 3, 0, 2, 0, 0, 0, 0, 0, 5, 3, 0, 2, 0, 4, 0, 25, 0, 16, 0, 0, 0, 16, 0, 0, 8, 16, 0, 5, 0, 0, 0, 0, 0, 25, 12, 0, 0, 0, 12, 0. The safesparse function would be used to efficiently calculate the dot product between a user rating matrix and its transpose matrix. resulting in the similarity matrix where each element represents the similarity between two users based on their movie ratings. What is the purpose of the sklearn function xmart, randomized range finder? A. To perform a randomized search for optimal hyperparameters in a machine learning model. B. To calculate the range of values for a given feature in a dataset. C. To randomly sample data points from a dataset. D. To generate random numbers within a specified range. E. All of the above. True. This function can be used to find suitable ranges for hyperparameters in a machine learning model. It randomly explores a given range to discover values that might lead to better model performance. True. By analyzing a dataset's features, it can identify the minimum and maximum values, providing a range for each feature. True. The function can be used to randomly sample data points from a dataset for tasks like model training or testing. This can be useful when dealing with large datasets. True. The function can generate random numbers within a specified range. This can be used for tasks like initializing parameters in machine learning models. True. The correct answer is E. All of the above. E. All of the above. Parameters that control the learning process of a machine learning model, not learned from data. Learning rate, number of layers in a neural network, regularization strength. In an image classification model, the number of layers in the neural network, the learning rate, and the regularization strength are hyperparameters that are tuned before training. These parameters determine how the model learns and generalizes to unseen data. A hyperparameter optimization technique that randomly samples hyperparameter values from a distribution. It explores a wider range of hyperparameter combinations compared to grid search. Suppose you want to train a support vector machine SVM model for spam detection. The hyperparameters include the regularization parameter C and the kernel type. Using randomized search, you can randomly select values for C and the kernel type from a specified distribution. Evaluate the model's performance, and identify the best hyperparameter configuration. Selecting a subset of data from a larger dataset for various purposes like model training, evaluation, or analysis, random sampling, stratified sampling, k-fold cross-validation. Imagine you have a dataset of customer reviews for a product. To train a sentiment analysis model, you can use random sampling to select a representative subset of reviews for training and another subset for testing the model's accuracy. This helps prevent overfitting and provides a realistic estimate of the model's performance. Creating a sequence of random numbers within a specified range. Used for various tasks like initializing model parameters, generating random data, or simulating processes. In a neural network, the initial weights and biases are typically initialized randomly. This randomness helps break symmetry in the network and allows for more diverse learning pathways. Random number generation is also crucial in simulations, such as Monte Carlo simulations, where random events are generated to analyze complex systems. Which statements are true regarding sklearn, utils, xmart, randomized SVD? A. It leverages random projections to approximate singular value decomposition SVD. B. It's generally faster than traditional SVD methods for large matrices. C. It can be utilized for dimensionality reduction and recommendation systems. D. All of the above. True. This statement is true. The core principle of randomized SVD is using random projections to create a low-rank approximation of the original matrix, thereby speeding up the SVD process. It leverages the fact that random projections can effectively capture the essential information in a dataset. True. This statement is true. Randomized SVD significantly outperforms traditional SVD methods, especially when dealing with large matrices. It achieves this by using random projections to reduce the computational complexity of the SVD algorithm. True. This statement is true. Randomized SVD is widely used for dimensionality reduction, as it allows you to select a smaller number of singular values to represent the data. It also plays a crucial role in recommendation systems, where it helps in finding latent relationships between users and items. True. This statement is true. As explained above, randomized SVD leverages random projections for approximate SVD, is faster for large matrices, and has applications in dimensionality reduction and recommendation systems. Therefore, all statements A, B, and C are correct. D. All of the above. Singular value decomposition SVD. SVD is a fundamental matrix factorization technique that decomposes a matrix into three matrices U and V. U and V are orthogonal matrices, and is a diagonal matrix containing singular values. SVD has applications in various fields, including recommendation systems, image compression, and dimensionality reduction. Consider a matrix A representing user ratings for movies. Performing SVD on A would decompose it into U and V. U represents users, V represents movies, and contains ratings information. By analyzing these matrices, we can understand user preferences and movie similarities, which is helpful for recommending movies. Random projections. Random projections are a method for dimensionality reduction by projecting high-dimensional data onto a lower dimensional space using random matrices. This process preserves the distances between data points, making it suitable for preserving essential information while reducing the number of features. Imagine a dataset containing 100 features. We can apply random projections to reduce the dimensionality to 10 features. This reduces the computational complexity without sacrificing important information. Dimensionality reduction. Dimensionality reduction aims to reduce the number of features in a dataset while preserving as much information as possible. It is often used for tasks like data visualization, noise reduction, and improving the performance of machine learning algorithms. In image classification, dimensionality reduction can be applied to reduce the number of pixels in an image, which can improve the speed and efficiency of image processing algorithms. Recommendation systems. Recommendation systems suggest items or content to users based on their past behavior and preferences. These systems leverage techniques like collaborative filtering and content-based filtering, which often rely on dimensionality reduction and matrix factorization methods. Online platforms like Netflix, Amazon, and Spotify use recommendation systems to suggest movies, products, and songs based on user preferences and past interactions. Image compression. Image compression techniques reduce the size of images while maintaining a reasonable level of quality. Techniques like JPEG compression use SVD to efficiently represent an image with fewer data points. JPEG compression uses SVD to represent an image with fewer coefficients, thereby reducing the file size. This allows for faster transmission and storage of images without significant loss of visual information. Principal Component Analysis (PCA). PCA is a dimensionality reduction technique that finds the principal components, which are orthogonal directions that capture the maximum variance in the data. It is used for data visualization, noise reduction, and feature extraction. In a dataset of customer demographics, PCA can be used to identify key dimensions, principal components that explain the most variation in customer behavior, helping businesses understand their target audience better. What is the primary purpose of the sklearn, utils, xmart, density function? A. Compute the determinant of a matrix. B. Calculate the density of a given dataset. C. Perform singular value decomposition SVD on a matrix. D. Compute the inverse of a matrix. E. All of the above. False. The sklearn, utils, xmart, density function is not designed for computing matrix determinants. Determinants are calculated using dedicated functions within libraries like NumPy. True. This is the primary function of sklearn, utils, xmart, density. It measures the proportion of non-zero elements in a matrix or array, providing insight into data sparsity. False. SVD is a separate matrix decomposition technique, not related to the sklearn, utils, xmart, density function. False. Calculating matrix inverses is handled by functions like NumPy, linalg.inv, not by the sklearn, utils, xmart, density function. False. As only choice B is correct, this option is incorrect. B. Calculate the density of a given dataset. Sparsity refers to the presence of many zero elements in a matrix or array. Sparse data is common in various domains, including natural language processing, recommender systems, and image processing. Matrix density is a measure of how many non-zero elements are present in a matrix. It is calculated as the ratio of non-zero elements to the total number of elements in the matrix. A higher density implies fewer zero elements. Understanding data sparsity guides data preprocessing decisions. For instance, when dealing with sparse data, one might consider using feature selection techniques to reduce the number of features or employing dimensionality reduction methods tailored for sparse data. Suppose you have a dataset of customer purchases with a large number of products. Many customers might purchase only a few products, resulting in a sparse matrix representing the purchase history. By assessing the density, you can decide whether to apply feature selection techniques to remove irrelevant products or use algorithms designed for sparse data, like sparse matrix factorization. For recommendation systems, sparse data characteristics affect the choice of algorithms. Certain algorithms, such as some linear models, perform less efficiently with dense data and might benefit from specialized algorithms designed for sparse data. Consider a task of predicting customer churn. A sparse matrix representing customer interactions can be used for this prediction. Since the interaction matrix is sparse, it might be advantageous to employ sparse-aware algorithms like sparse logistic regression or sparse decision trees, which are often more efficient than dense data algorithms. Dense matrices require more memory and computational resources. Understanding sparsity allows for optimization by using sparse data structures and algorithms that exploit the zero elements, thereby reducing storage and computational overhead. In image processing, images can be represented as matrices. When dealing with images with large areas of uniform color, e.g., a sky in a photograph, the image matrix can be sparse. By storing and processing the image using a sparse representation, memory usage and computational time can be significantly reduced. What does the sklearn, utils, xmart, weighted mode function calculate? A. The mode of a 1D array, taking into account weights. B. The mode of a 2D array, taking into account weights. C. The weighted average of a 1D array. D. The weighted average of a 2D array. E. All of the above. Answer. Correct. The weighted mode function calculates the mode of a 1D array, considering weights assigned to each element. True. Answer. Correct. For multidimensional arrays, it calculates the mode for each column, taking weights into account. True. Answer. Incorrect. While the function considers weights, it doesn't calculate a weighted average. It determines the mode, which is the most frequent element. False. Answer. Incorrect. Similar to choice C, the function doesn't calculate weighted averages. It focuses on identifying the most frequent elements' modes in the arrays. False. Answer. Correct. As explained in the previous choices, the weighted mode function handles both 1D and 2D arrays, taking weights into account to determine the mode. True. E. All of the above. Concept weighted mode. The weighted mode adapts the traditional mode concept by incorporating weights for each data point. These weights influence how much each data point contributes to determining the mode. In recommendation systems, weighted mode can be used to predict user preferences. For instance, items with higher ratings or more user interactions would receive higher weights, influencing the final recommendation. This allows for a more nuanced understanding of user preferences based on various factors. Related concepts. The mode is the value that appears most frequently in a dataset. It's a measure of central tendency used to understand the typical or most common value. In fashion trends, the mode can identify the most popular clothing styles or colors based on sales data. This information is valuable for businesses to understand customer preferences and adjust their inventory accordingly. Related concepts. A weighted average considers the relative importance of different data points by assigning them weights. The weights reflect the influence of each data point on the overall average. In calculating a student's GPA grade point average, different courses may have different weightings based on their credit hours. This weighted average reflects the overall academic performance considering the relative importance of each course. Related concepts. NumPy arrays are fundamental data structures in Python used to represent and manipulate numerical data efficiently. They provide a powerful tool for mathematical operations and data analysis. In image processing, images are typically represented as multidimensional NumPy arrays. This representation enables efficient manipulation of image data, such as applying filters, resizing, and performing other image processing tasks. Related concepts. sklearn is a popular Python library for machine learning. It provides a wide range of algorithms and tools for tasks like classification, regression, clustering, and more. In spam detection, sklearn can be used to train machine learning models to identify spam emails based on features like the presence of certain words or email patterns. Related concepts. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data. In healthcare, data science can be used to analyze patient data to identify patterns and predict health outcomes. This information can support personalized treatments and improve patient care. Related concepts. Machine learning is a subset of artificial intelligence that enables computers to learn from data without explicit programming. It focuses on developing algorithms that allow systems to improve their performance over time. In self-driving cars, machine learning is used to train algorithms that interpret sensor data like cameras, LiDAR, and radar and make decisions about steering, braking, and acceleration. Related concepts. Statistical analysis involves collecting, organizing, analyzing, and interpreting data to extract meaningful information and draw conclusions. It provides a framework for understanding patterns and trends in data. In market research, statistical analysis is used to analyze survey data to understand customer preferences, market trends, and competitive landscape. This information helps companies make informed decisions about product development, marketing strategies, and pricing. Let's say we have a 1D array representing the number of times a particular product was purchased in a week: 3, 5, 2, 1, 4, 2, 3. Now, assume we have corresponding weights for each day representing customer satisfaction: 0.8, 0.9, 0.7, 0.6, 1.0, 0.8, 0.9. Using weighted mode, we want to find the product purchase day that had the highest weighted frequency. Considering customer satisfaction. From sklearn, utils, xstmart import weighted mode. Array 3, 5, 2, 1, 4, 2, 3. Weights: 0.8, 0.9, 0.7, 0.6, 1.0, 0.8, 0.9. Weighted mode result. Weighted mode array. Weights. Print weighted mode result. The output will be a tuple containing the mode, in this case, the day with the highest weighted frequency of product purchases, the count of occurrences of the mode, and the indices of the mode in the array. This helps identify the day where the product was purchased most frequently. Considering customer satisfaction. What is the primary purpose of the sparse-finks module in scikit-learn's utils package? To provide advanced linear algebra operations for dense matrices. To offer specialized functions designed to efficiently handle sparse matrices. To facilitate the conversion of sparse matrices to dense formats. All of the above. Incorrect. The sparse-finks module is specifically designed for sparse matrices, not dense matrices. A. To provide advanced linear algebra operations for dense matrices. Correct. The sparse-finks module provides optimized functions for sparse matrices, improving efficiency and reducing memory usage. B. To offer specialized functions designed to efficiently handle sparse matrices. Incorrect. While conversion between sparse and dense formats is possible, it's not the primary purpose of sparse-finks. It's focused on efficient operations within the sparse format. C. To facilitate the conversion of sparse matrices to dense formats. Incorrect. Only option B is correct. Options A and C are not the primary focus of the sparse-finks module. D. All of the above. To offer specialized functions designed to efficiently handle sparse matrices. Matrices with a high proportion of zero elements, allowing for efficient storage and computation compared to dense matrices. Consider a user item interaction matrix in a recommendation system. If you have 100 users and 1000 items, but only a few users interacted with each item, most entries would be 0. Making it a sparse matrix. 1. Sparse matrices. A package within the scikit-learn library containing utility functions that support various machine learning tasks, including sparse data handling. The utils package provides functions for data preprocessing, model evaluation, and other supporting tasks, making it essential for working with scikit-learn. 2. Scikit-learn utils package. A module within scikit-learn's utils package specializing in efficiently handling sparse matrices, providing functions optimized for sparse data structures. Functions like CSR matrix ... for matrix multiplication, CSR matrix transpose, and CSR matrix Mean within sparse finks are designed to work efficiently with sparse matrices. 3. Sparse finks module. The ability to store and process sparse matrices effectively, avoiding unnecessary computations and memory usage compared to handling them as dense matrices. Instead of storing all 100,000 entries in a 100 by 1000 dense matrix, sparse matrix representations store only the non-zero entries in their positions, drastically reducing memory requirements. 4. Efficiency in sparse data handling. A measure of similarity between two vectors or rows columns in a matrix. Often used in applications like recommendation systems and collaborative filtering. Given two user vectors representing their interactions with products, cosine similarity measures the angle between them, with smaller angles indicating greater similarity. 5. Cosine similarity example. What does the sklearn, utils, sparse finks, income invariance axis function do in the context of sparse arrays? A. Calculates the mean and variance of a sparse array along a specified axis. B. Converts a dense array to a sparse array. C. Performs incremental mean and variance calculations for a sparse array along a specified axis. D. All of the above. False. While the function calculates mean and variance, it does so incrementally, not in a single step. This means it updates the calculations as new data comes in. LT font style font size 16 px the income invariance axis function is designed for efficiently calculating the mean and variance of sparse arrays in a way that is memory efficient and suitable for incremental updates. LT font GT. False. This is not the function's purpose. It works specifically with sparse arrays, not converting between array types. LT font style font size 16 px GT. It operates on sparse arrays, which are data structures that efficiently store data with many zeros. This is crucial for handling large datasets with sparse features, common in areas like text processing and recommender systems. LT font TGT. True. This is the accurate description of the function's behavior. It calculates mean and variance incrementally, meaning it updates these values as new data becomes available. LT font style font size 16 px the incremental nature allows you to update the mean and variance calculations as new data arrives, without having to recalculate from scratch. This is valuable when processing data in streaming scenarios or when dealing with large datasets that don't fit into memory at once. LT font GT. False. This is incorrect because option A is not fully accurate. It is designed for incremental updates, not single-step calculations. LT font style font size 16 px the income invariance axis function is designed for efficiently calculating the mean and variance of sparse arrays in a way that is memory efficient and suitable for incremental updates. LT font GT. C. Performs incremental mean and variance calculations for a sparse array along a specified axis. Efficiently store data with many zero values. Common in NLP, recommender systems. Example: a sparse array for movie ratings might have rows for users and columns for movies. Most entries would be zeros, representing movies a user has rated, while non-zero values indicate the ratings. Updating calculations based on new data without recalculating from scratch. Example: imagine tracking the average height of students in a class. With each new student, you can update the average without recalculating it from scratch, which is more efficient than starting from the beginning every time. Central measures of a dataset's distribution. Mean, average, variance, spread. Example: consider student scores on a test. The mean score tells you the average performance. while the variance indicates how much the scores vary around that average. A high variance means scores are spread out, while a low variance means they are clustered together. Natural language processing (NLP) analyzing text data often involves sparse matrices, e.g. word counts. Recommender systems user item interaction data is often sparse, making incoming variance access ideal for calculating mean and variance of user preferences or item ratings. Image processing sparse representations of images, e.g. compressed formats, can benefit from incremental calculations. Bioinformatics analyzing genomic data often involves sparse matrices, e.g., gene expression profiles. Large-scale machine learning handling massive datasets with sparse features efficiently is crucial. For training models, you have a sparse matrix representing customer data with columns for age, income, and purchase history. You need to scale each column to have zero mean and unit variance. Which approach would you use? A. Apply standard scaler directly to the sparse matrix. B. Use sparse finks, in-place column scale for efficient scaling. C. Convert the sparse matrix to a dense array and then apply standard scaler. D. All of the above. This is a valid approach as standard scaler can handle both dense and sparse data. However, it can be computationally expensive, especially for large matrices, as it internally converts the sparse matrix to a dense array for processing. True. 1. LTBGT standard scaler LTBGT. This is a general-purpose scaler that can be used on both dense and sparse data. However, when applied directly to a sparse matrix, it can be computationally expensive, especially for large matrices, as it internally converts the sparse matrix to a dense array for processing. This is the most efficient approach for scaling large sparse matrices because it operates directly on the sparse matrix, preserving its sparse representation. This minimizes memory usage and improves processing speed. True. 2. LTBGTS sparse finks, in-place column scale LTBGT. This function is specifically designed for efficient column-wise scaling of sparse matrices. It operates directly on the sparse matrix, preserving its sparse representation, and scales each column independently, making it a more efficient option for large datasets. This is a valid approach but can lead to a significant increase in memory usage and computation time, especially for large sparse matrices. Converting to a dense array defeats the purpose of using a sparse matrix in the first place. True. 3. LTBGT convert to dense array LTBGT. Converting a sparse matrix to a dense array before applying standard scaler is a valid approach, but it can result in a significant increase in memory usage and computation time, especially for large sparse matrices. Since all the above methods are valid ways to scale sparse matrices, this option is correct. True. All options are valid ways to scale sparse matrices, but they differ in efficiency and ease of use. D. All of the above. Data structures that efficiently store data with a high proportion of zeros. These are crucial for handling large datasets with many features and sparse data patterns. A recommendation system storing user item interactions, where most users haven't interacted with most items, resulting in a sparse matrix. A transformer in sklearn that scales features to have zero mean and unit variance. It is commonly used for preprocessing data before applying machine learning algorithms. Scaling the features of a dataset for a machine learning model like linear regression to improve its performance. A function in sklearn's sparse finks module that efficiently scales columns of a sparse matrix. In place, it preserves the sparse representation, minimizing memory usage and improving processing speed for large sparse datasets. Scaling a large sparse matrix representing customer purchase history to improve the efficiency of a recommendation algorithm. Recommendation systems. Scaling user item interaction matrices, which are typically sparse, can improve the performance of recommendation algorithms. Text analysis. When dealing with document term matrices, which are often sparse due to the presence of a large vocabulary, scaling can help improve the accuracy of text classification models. Bioinformatics. In genetic data analysis, where datasets often have a high proportion of zeros, scaling is essential for processing and analyzing these sparse matrices efficiently. 25, 30, 0, 0, 40, 5000, 7500, 0, 0, 1000, 10, 15, 0, 0, 20. This data represents a sparse matrix where most entries are zeros. We can use sparse finks, in-place column scale to scale each column to have zero mean and unit variance. This is more efficient than converting the sparse matrix to a dense array and applying standard scaler. What is the primary purpose of the sklearn, utils, sparse finks, in-place column scale function in scikit-learn? A. To perform feature scaling on dense matrices. B. To normalize the values within each column of a sparse matrix. C. To convert a dense matrix to a sparse matrix. D. To calculate the mean and standard deviation of a sparse matrix. E. All of the above. Feature scaling for dense matrices while primarily designed for sparse matrices. In-place column scale can also be used to perform feature scaling on dense matrices, ensuring that all features have a similar range. This can be helpful in improving the performance of certain machine learning algorithms. True. Normalization of sparse matrix columns. This is the core functionality of in-place column scale. It rescales the values within each column of a sparse matrix so that they fall within a specific range, typically between 0 and 1. This is crucial for many machine learning algorithms that assume features have a similar scale. True. Dense to sparse matrix conversion. In-place column scale can be used to convert a dense matrix into a sparse matrix by setting the d-type parameter to CSR. This allows efficient storage and processing of large datasets. True. Mean and standard deviation calculation. In-place column scale can calculate the mean and standard deviation of a sparse matrix using the with mean and with std parameters. This information can be valuable for analyzing the data and understanding the distribution of features. True. The in-place column scale function is a versatile tool in scikit-learn for handling sparse matrices. It can be used for the following purposes. True. E. All of the above. Sparse matrices are data structures that efficiently store matrices with a large number of zero elements. They are crucial for handling large datasets in machine learning and data analysis. Sparse matrices are commonly used in various applications, including text processing representing text data where words or tokens are features, recommender systems representing user item interactions, image processing representing images with high sparsity, social network analysis representing relationships in social networks. Feature scaling transforms features to a common scale, often between 0 and 1 or a standardized range with mean 0 and standard deviation 1. This helps improve the performance of certain machine learning algorithms by preventing features with larger scales from dominating the learning process. Feature scaling is essential in machine learning to ensure that features have a similar scale, preventing algorithms from being biased towards features with larger values. It is used in various algorithms like linear regression to avoid features with larger scales dominating the regression coefficients. K-means clustering to avoid clusters being influenced by features with larger scales. Support vector machines to improve the performance of the algorithm by ensuring that all features have a similar influence on the decision boundary. Normalization is a type of feature scaling that transforms data to a specific range, typically between 0 and 1. It is often used in machine learning to standardize input data and improve the performance of algorithms. Normalization is widely used in machine learning for various purposes, including neural networks to prevent exploding or vanishing gradients during training, image classification to standardize pixel values between 0 and 1, text classification to scale word frequencies or TF-IDF values. Scikit-learn is a popular Python library for machine learning, offering a comprehensive set of tools for data analysis, model building, and prediction. Scikit-learn provides a wide range of tools for machine learning practitioners, including classification algorithms, logistic regression, support vector machines, decision trees, random forests, etc., regression algorithms, linear regression, ridge regression, lasso regression, etc., clustering algorithms, K-means clustering, DBSCAN, etc., dimensionality reduction techniques, principal component analysis, PCA, linear discriminant analysis, LDA, etc., model selection and evaluation techniques, cross-validation, grid search, etc. In-place column scale is a powerful function that provides a flexible and efficient way to scale columns of sparse matrices, making it a valuable tool for machine learning practitioners. The in-place column scale function in scikit-learn is particularly useful for handling sparse datasets. In machine learning, it can be used for various purposes, including scaling text features, scaling features in text processing to improve the performance of text classification models, normalizing recommender system data, scaling user item interactions to ensure fair representation of different user preferences, preprocessing sparse image data, scaling features in sparse image datasets for image recognition tasks, analyzing social network data, scaling features in sparse social network data to identify patterns and relationships. What does the sklearn, utils, sparsefinx, in-place raw scale function accomplish when applied to a sparse matrix? A. Normalizes each row of the sparse matrix by dividing it by its Euclidean norm. B. Scales each row of the sparse matrix by subtracting the row's mean and dividing by its standard deviation. C. Reshapes the sparse matrix, modifying its rows and columns. D. All of the above. Correct. The in-place raw scale function does normalize each row of the sparse matrix by dividing it by its Euclidean norm. This ensures that all rows have a unit length, which can be beneficial for certain machine learning algorithms. Correct. The function also scales each row by subtracting the row's mean and dividing by its standard deviation. This standardizes the data within each row, making it easier for algorithms to learn patterns and relationships. Correct. Finally, in-place raw scale can reshape the sparse matrix. While not always necessary, it can adjust the matrix's dimensions, potentially changing the number of rows and columns. Correct. Since all the previous operations are performed by the in-place raw scale function, the correct answer is all of the above. D. All of the above. Sparse matrices are matrices where most of the elements are zero. They are efficient for storing and manipulating data with a high number of zeros. Commonly found in natural language processing. computer vision, and recommender systems. Natural language processing representing documents as term document matrices where each row represents a document and each column represents a word. The matrix is sparse because most words won't appear in each document. Recommender systems representing user-item interactions as a sparse matrix where each row represents a user, and each column represents an item. This is sparse because users typically only interact with a small fraction of all available items. Normalization scales data to a specific range, typically between 0 and 1. This is useful when different features have different scales, as it can prevent features with larger values from dominating the learning process. Image processing normalizing pixel intensities to improve image contrast and enhance feature extraction for tasks like object recognition and image classification. Machine learning normalizing features in datasets with diverse scales to improve the performance of algorithms like k-nearest neighbors KNN, which rely on distance calculations. Scaling transforms data to have a similar range and/or mean. It's often used to center data around 0 and have a unit variance. This can improve algorithm performance and reduce bias. Support vector machines SVM scaling features to ensure that all features have similar influence on the decision boundary and prevent features with larger scales from dominating. Linear regression scaling features to improve the numerical stability of the model fitting process and prevent issues with large feature values. The Euclidean norm or L2 norm measures the length of a vector. It's calculated as the square root of the sum of the squares of each element in the vector. In the context of sparse matrices, the Euclidean norm of a row measures the overall magnitude of the non-zero values in that row. Machine learning calculating the Euclidean distance between data points is a measure of similarity. This is used in various algorithms like KNN and k-means clustering. Computer vision computing the Euclidean distance between features in images to perform tasks like image matching and object recognition. 1, 2, 3, 1, 2, 3, 1, 4. The mean is the average value of a set of numbers, while the standard deviation measures the spread or variability of the data around the mean. Scaling using mean and standard deviation involves centering the data around 0 and scaling data to have unit variance. Machine learning scaling features to have 0 mean and unit variance is a common pre-processing step for many algorithms, including linear regression, logistic regression, and neural networks. This helps to improve the numerical stability of the optimization process and reduce the impact of outliers. Statistical analysis using mean and standard deviation to describe and summarize data distributions and identify potential outliers. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 5, 3. 1, 3, 2, 3, 3. 3, 4, 3, 5, 3, 5, 1, 2. What is the primary purpose of the sklearn, utils, sparse finks, in-place swap-row function? A. To convert a dense matrix into a sparse matrix. B. To perform in-place row swapping within a sparse matrix. C. To calculate the inverse of a sparse matrix. D. To perform element-wise multiplication of sparse matrices. A. To convert a dense matrix into a sparse matrix. False. This function is not related to dense to sparse matrix conversion. It focuses solely on sparse matrix operations. B. To perform in-place row swapping within a sparse matrix. True. This is the correct answer. The function's primary purpose is to efficiently swap rows within a sparse matrix without creating a copy. It modifies the matrix in place. directly altering the original data. Imagine a sparse matrix representing customer purchase data, where each row represents a customer and each column represents a product. If you want to group customers based on their recent purchases, you could swap rows to bring customers with similar buying patterns together. In-place swap row would be useful for this operation. C. To calculate the inverse of a sparse matrix. False. Calculating the inverse of a sparse matrix is a different operation than row swapping. This function doesn't handle matrix inversion. D. To perform element-wise multiplication of sparse matrices. False. Element-wise multiplication is another distinct operation on sparse matrices. The function focuses on row swapping, not element-wise operations. B. To perform in-place row swapping within a sparse matrix. Related concepts. Sparse matrices. Matrices with a high proportion of zero entries. These are efficient to store and manipulate, especially for large datasets. Examples include customer-product interaction matrices, document term matrices, and network adjacency matrices. Consider a matrix representing the connections between users on a social network. If there are millions of users, but each user only interacts with a few others, the matrix would be sparse. In-place operations. Operations that directly modify the original data structure without creating a new copy. This can be beneficial for memory efficiency, especially when working with large datasets. Sorting an array in place means arranging its elements directly within the existing array without allocating a new array. Sklearn, a popular Python library for machine learning, offering tools for data preprocessing, model training, and evaluation. Sklearn provides algorithms for classification, regression, clustering, dimensionality reduction, and more. Sparse matrix operations. Specialized functions for manipulating sparse matrices efficiently. These operations take advantage of the sparsity to reduce computational overhead. Operations like matrix addition, multiplication, and transposition need to be optimized for sparse matrices to avoid unnecessary calculations on zero elements. Use cases. 1. Reordering data. This function can be used to rearrange rows within a sparse matrix based on specific criteria, e.g., sorting by feature values. You might reorder rows to group similar data points together. For example, if you have customer data, you could swap rows to bring customers with similar purchase histories closer in the matrix. 2. Implementing algorithms. Certain machine learning algorithms, e.g., some clustering algorithms may require row swapping for efficient processing. Some clustering algorithms, like k-means, can benefit from reordering data points during the clustering process. This can improve computational efficiency and accuracy. What is the primary functionality of sklearn? Utils, sparse finks, in-place swap column. A. It performs in-place modification of a sparse matrix, swapping the values of two specified columns. B. It converts a dense matrix into a sparse matrix representation. C. It calculates the dot product of two sparse matrices. D. All of the above. LT font style font size 16 px sklearn, utils, sparse finks, in-place swap column is specifically designed for modifying sparse matrices. It directly modifies the input sparse matrix by swapping the values of two specified columns, making it an efficient method for in-place data transformation. LT font GT. True. The text explains that the function is specifically designed for modifying sparse matrices and it directly modifies the sparse matrix by swapping values of two specified columns. This is a direct explanation of the function's primary functionality as stated in choice A. LT font style font size 16 px GT. It converts a dense matrix into a sparse matrix. Representation LT font GT. False. The text explicitly states that the function is for modifying sparse matrices, not converting dense matrices. This contradicts choice B. LT font style font size 16 px GT. It calculates the dot product of two sparse matrices. LT font GT. False. The text mentions in place modification of sparse matrices by swapping columns, not calculating dot products. This contradicts choice C. LT font style font size 16 px all of the above. LT font GT. False. Since choices B and C are incorrect, choice D cannot be correct as it includes them. The text only mentions in place column swapping, not the functionalities in B and C. A. LT font style font size 16 px GT1. Feature engineering. Swapping columns of sparse matrices can be helpful in feature engineering tasks, particularly in text processing where features may represent different word occurrences. LT font GT. In text processing, a sparse matrix can represent word occurrences in a document. Swapping columns can change the order of these features, impacting the feature representation for analysis or model training. LT font style font size 16 px GT2. Data preprocessing. Swapping columns might be necessary to adjust the order of features in a sparse matrix during data preprocessing for specific machine learning algorithms. LT font GT. Certain algorithms might require features in a specific order. Column swapping can be used to rearrange features in a sparse matrix before applying these algorithms. LT font style font size 16 px GT. Sparse matrice SLT font GT. Sparse matrices are efficient representations of matrices with many zero values, common in text processing or high-dimensional datasets. They save memory and computational resources. LT font style font size 16 px GT. In place modification. LT font GT. This refers to altering the original data structure directly without creating a copy. It improves performance and reduces memory consumption, especially for large datasets. LT font style font size 16 px GT. Column swapping. LT font GT. Rearranging the positions of columns in a matrix, changing the order of features or variables in a dataset. LT font style font size 16 px GT. Efficiency 20 GT. In-place operations are often more efficient than creating copies because they minimize memory usage and unnecessary data movement, leading to faster processing. What does the sklearn, utils, sparse finks, mean variance access function calculate in a sparse matrix? A. Mean and variance of the rows only. B. Mean and variance of the columns only. C. Mean and variance of both rows and columns. D. Mean and variance along a specified axis. Incorrect. The mean variance access function allows calculation along both rows axis 0 and columns axis 1. A. Mean and variance of the rows only. Incorrect. The mean variance access function allows calculation along both rows axis 0 and columns axis 1. B. Mean and variance of the columns only. Incorrect. The function calculates mean and variance along a specified axis, either rows axis 0 or columns axis 1. C. Mean and variance of both rows and columns. Correct. The mean variance access function calculates mean and variance along a specified axis. You can choose to calculate these statistics for rows axis 0 or columns axis 1. D. mean and variance along a specified axis. D. Sparse matrices are data structures optimized for storing data with a high proportion of zeros. This is particularly useful for datasets with many features but few non-zero values, reducing memory usage and computational complexity. They're often used in natural language processing (NLP), recommender systems, and image processing. Sparse matrices data structures optimized for storing data with a high proportion of zeros. Axis in NumPy refers to the dimension along which operations are performed. For example, in a 2D array matrix, axis 0 represents rows and axis 1 represents columns. Specifying an axis lets you control how functions like mean-variance axis operate on the data. Axis in NumPy specifies the dimension along which calculations are performed. Mean and variance are statistical measures that provide insights into the distribution of data. The mean represents the average value, while variance quantifies the spread or dispersion of the data points around the mean. These measures are fundamental in various data analysis tasks, including data preprocessing, feature engineering, and model evaluation. Mean and variance statistical measures describing the central tendency in spread of data. The sklearn, utils, sparseFinks module in scikit-learn provides a collection of functions specifically designed for working with sparse matrices. These functions are optimized for handling sparse data efficiently and effectively. sklearn, utils, sparseFinks module containing functions for working with sparse matrices in scikit-learn. The mean-variance axis function is particularly useful for data preprocessing tasks such as scaling and normalization. By calculating the mean and variance of features along a specified axis rows or columns, you can standardize the data to have a consistent range and scale, which can improve the performance of machine learning models. Data preprocessing calculate mean and variance for scaling or normalizing data. Understanding the distribution of features in a sparse dataset is crucial for feature analysis. The mean-variance axis function allows you to calculate the mean and variance of individual features, columns or rows in a sparse matrix, providing insights into the central tendency and variability of the features. This information can help identify potentially informative or redundant features. Feature analysis understands the distribution of features in a sparse dataset. Certain machine learning algorithms, such as linear regression and support vector machines (SVMs), require mean and variance information for optimal performance. The mean-variance axis function can provide these statistics, enabling you to train models effectively on sparse datasets. Model training provides statistics for algorithms that require mean and variance information. 1, 0, 2, 0, 3, 0, 4, 0, 0, 0, 10431.67, 1.67, 0, 1 to 1.6720 to 1.6724 to 1.6723 2.22, 2.22, 1, 10431.67, 1.67, 1, 1 to 1.6720 to 1.6724 to 1.6723 2.22, 2.22. What does the sklearn, utils, sparseFinks, in-place column scale function do in scikit-learn? A. Normalizes the columns of a CSR matrix in place, modifying the original matrix. B. Scales the columns of a CSR matrix in place, modifying the original matrix. C. Transposes the columns of a CSR matrix in place, modifying the original matrix. B. Scales the columns of a CSR matrix in place, modifying the original matrix. In place column scale does not normalize the columns. Normalization typically involves rescaling data to a range between 0 and 1. While scaling can involve different methods like standardization or min-max scaling. A. Normalizes the columns of a CSR matrix in place, modifying the original matrix. This is the correct answer. The function scales each column of the CSR matrix by dividing each element in the column by a maximum value in that column. It does this in place, meaning it modifies the original CSR matrix directly without creating a copy. B. Scales the columns of a CSR matrix in place, modifying the original matrix. In place column scale does not transpose the columns of the CSR matrix. Transposing involves swapping rows and columns. This function specifically focuses on scaling the values within each column. C. Transposes the columns of a CSR matrix in place, modifying the original matrix. Data preprocessing. This function is useful for scaling sparse data before feeding it to machine learning models. Scaling data can help to improve model performance and prevent numerical instability. Data preprocessing. This function is useful for scaling sparse data before feeding it to machine learning models. Scaling data can help to improve model performance and prevent numerical instability. Feature engineering. You can use this function to scale specific features in a sparse dataset, which can help to improve model interpretability. Feature engineering. You can use this function to scale specific features in a sparse dataset, which can help to improve model interpretability. Efficiency. The in-place modification of the CSR matrix can be more efficient than creating a new matrix, especially for large sparse datasets. Efficiency. The in-place modification of the CSR matrix can be more efficient than creating a new matrix, especially for large sparse datasets. CSR matrix. A compressed sparse row CSR matrix is a sparse matrix data structure optimized for efficient row-wise operations. It's commonly used in scikit-learn for representing sparse data. CSR matrix. A compressed sparse row CSR matrix is a sparse matrix data structure optimized for efficient row-wise operations. It's commonly used in scikit-learn for representing sparse data. In-place modification. This means that the function directly modifies the original data structure in this case, the CSR matrix, without creating a new copy. This can be beneficial for efficiency, especially when working with large datasets. In-place modification. This means that the function directly modifies the original data structure in this case, the CSR matrix, without creating a new copy. This can be beneficial for efficiency, especially when working with large datasets. Data scaling. This involves transforming data to a common scale to prevent certain features from having an undue influence on the model. Common scaling methods include normalization, standardization, and min-max scaling. Data scaling. This involves transforming data to a common scale to prevent certain features from having an undue influence on the model. Common scaling methods include normalization, standardization, and min-max scaling. Which of the following statements accurately describe the purpose of scikit-learn's sparse thinks fast module? A. It provides optimized algorithms for performing operations on sparse matrices, particularly focusing on efficiency and memory usage. B. It allows for efficient handling of sparse data, leveraging techniques like sparse matrix formats and vectorization. C. It offers tools for converting dense matrices to sparse representations, improving computational performance in scenarios with many zero elements. D. All of the above. True. This statement is correct and aligns with the explanation provided for sparse-thinks-fast. The module prioritizes efficiency and memory usage by using optimized algorithms for sparse matrix operations. True. This statement is also correct. Sparse-thinks-fast leverages sparse matrix formats like CSR and CSC, which are efficient representations for data with many zeros. It also utilizes vectorization to speed up computations. True. This statement is correct as well. Sparse-thinks-fast provides functionality to convert dense matrices into sparse formats. This conversion helps improve computational performance by reducing memory usage and optimizing operations for sparse data. True. Since statements A, B, and C are all correct, the statement all of the above is also correct. This encapsulates the overall purpose of the sparse-thinks-fast module. D. All of the above. Matrices with a large percentage of zero elements. They are efficient for representing data with high dimensionality and sparsity. Recommender systems user preferences. Natural language processing word occurrences. Computer vision image features. Machine learning collaborative filtering, linear regression. 1, 0, 0, 2, 0, 0, 3, 0, 0, 4, 0, 0. This matrix has a high percentage of zero elements, making it a good candidate for sparse representation. Efficient data structures for storing and manipulating sparse matrices. Examples include compressed sparse row CSR and compressed sparse column CSC. Efficient storage and processing of sparse data in recommender systems, NLP, and machine learning algorithms. 1, 2, 3, 4, 0, 3, 2, 1, 0, 1, 2, 4. This represents the sparse matrix above in the CSR format. It stores only the non-zero elements and their positions, performing operations on entire arrays or matrices using specialized functions, eliminating the need for explicit loops. This significantly improves computational performance. Fast matrix multiplication, element-wise operations, and other computations in scientific computing and machine learning. 1, 2, 3, 4, 5, 6, 7, 8, 9. Dense matrix 10. This adds 10 to each element of the matrix without needing explicit loops, showcasing the efficiency of vectorized operations. A widely used machine learning library in Python. It provides various algorithms, tools, and utilities for tasks like classification, regression, clustering, and more, building models for image recognition, natural language processing, and other machine learning applications. sklearn, linear model, linear regression. This creates a linear regression model in scikit-learn, demonstrating the use of the library for building machine learning models. A submodule within scikit-learn that focuses on providing optimized functions for efficient operations on sparse matrices. Optimizing sparse matrix operations in recommender systems, NLP, and machine learning algorithms. SIPI, sparse, CSR matrix. Sparse-thinks-fast CSC.sparse matrix. This example uses sparse-thinks-fast for efficient dot product operation on a sparse matrix in CSC format, demonstrating the module's application in sparse matrix computations. You are working with a large sparse dataset. You need to normalize the data to ensure each row has a unit L1 norm sum of absolute values equals 1. Which scikit-learn function would you use for in-place normalization? A. sklearn, preprocessing, normalize x, normal1. B. sklearn, utils, sparse-thinks-fast in-place CS row normalizer 1x. C. sklearn, Preprocessing, min-max scalar feature range 0, 1. D. sklearn, preprocessing, standard scalar. False. While normalize with normal1 performs L1 normalization, it doesn't do it in place. It returns a new normalized array instead of modifying the original one. LT font style font size 18px GT LTBGTI and place normalization LTBGT LT font TGT LT font style font size 14px modifying the original data directly without creating a copy. This saves memory and is efficient for large datasets. LT font GT. True. This is the correct function. In-place CS row normalizer 1 is specifically designed for in-place L1 normalization of sparse matrices. In CSR format, it directly modifies the input matrix by dividing each row by its L1 norm, ensuring the row sums to 1. LT font style font size 18px GT LTBGT CSR compressed sparse row formatter TBGT LT font TGT LT font style font size 14px GTA storage format for sparse matrices that efficiently represents non-zero elements, making it suitable for large sparse data sets. LT font GT LT font style font size 18px GT LTBGT L1 normalization LTBGT LT font TGT LT font style font size 14px rescaling each row of a matrix so that the sum of absolute values of the elements in each row equals 1. This is useful when the magnitudes of features vary widely. LT font GT LT font style font size 18px GT LTBGTI and place normalization LTBGT LT font TGT LT font style font size 14px modifying the original data directly without creating a copy. This saves memory and is efficient for large datasets. LT font GT. False. Min-max scalar performs feature scaling, mapping values to a specified range 0, 1. It doesn't specifically target L1 normalization and may not be appropriate for sparse data. LT font style font size 18px GT LTBGT L1 normalization LTBGT LT font TGT LT font style font size 14px rescaling each row of a matrix so that the sum of absolute values of the elements in each row equals 1. This is useful when the magnitudes of features vary widely. LT font GT. False. Standard scalar standardizes features by subtracting the mean and dividing by the standard deviation. This is suitable for dense data but may not be ideal for sparse data where the mean and standard deviation calculations can be misleading. LT font style font size 18px GT LTBGT L1 normalization LTBGT LT font TGT LT font style font size 14px rescaling each row of a matrix so that the sum of absolute values of the elements in each row equals 1. This is useful when the magnitudes of features vary widely. LT font GT. B. sklearn, utils, sparsefinx fasten place CS row normalizer 1x. Data with a large proportion of zero values. This is common in text processing, recommender systems, and image analysis. Consider a document term matrix where each row represents a document and each column represents a word. In this matrix, most cells would be 0 since a document really contains all the words in a vocabulary. Text classification representing documents as sparse vectors, where each element represents the frequency of a particular word in the document. A storage format for sparse matrices that efficiently represents non-zero elements. making it suitable for large sparse data sets. Imagine a sparse matrix with a few non-zero elements. CSR format stores only the non-zero values, their row and column indices, and the starting index of each row in the array. This reduces memory usage compared to storing all values. Rescaling each row of a matrix so that the sum of absolute values of the elements in each row equals 1. Suppose a matrix row contains values 2, 4, -1, 0. The L1 norm is 2, 4, 1, 0, 7. To normalize, each element is divided by 727. 47, -17, 07. The sum of absolute values is now 1. Recommendation systems normalizing user-item interaction matrices to account for users with different levels of activity, number of ratings given. Modifying the original data directly, without creating a copy. This saves memory and is efficient for large datasets. Instead of creating a new copy of the matrix and performing normalization on the copy, the in-place CS row normalizer 1 function directly modifies the original sparse matrix in CSR format. Text classification normalizing term frequency vectors for documents. Recommendation systems normalizing user-item interaction matrices. Image processing normalizing pixel intensities in sparse image representations. What does the function in-place CS row normalizer 2 in scikit-learn's sparseFinks fast module do? A. Performs L2 normalization on each row of a sparse CSR matrix in place. B. Converts a dense matrix to a sparse CSR matrix. C. Calculates the L2 norm of a sparse CSR matrix. D. All of the above. L2 normalization. It performs L2 normalization on each row of a sparse CSR matrix, ensuring that the norm of each row is 1. This is commonly used in machine learning to prevent features with larger magnitudes from dominating the model. X20. Correct. The in-place CS row normalizer 2 function is designed to work with sparse CSR matrices, not for converting dense matrices. Incorrect. In-place modification. The in-place part is key. The function modifies the input matrix directly, saving memory and computational resources. Especially useful when dealing with large datasets. X20. This implies it's doing more than just calculating the L2 norm. Incorrect. CSR matrix handling. The function specifically works with matrices in the compressed sparse row CSR format, a very efficient way to store sparse matrices. X20. Since the function performs L2 normalization, modifies the matrix in place, and works with CSR matrices, it fulfills all the options. X20. Correct. D. All of the above. Sparse matrices. These are matrices where most of the elements are 0. They are very common in data science, especially when dealing with textual or categorical data. For example, in a text dataset, where each row represents a document and each column represents a word, most documents would contain only a small fraction of the total words. X20. This results in a sparse matrix. X20. In text classification, a document might have thousands of words, but only a few words are relevant to its category. A sparse matrix efficiently stores this information, reducing memory usage. CSR compressed sparse row format, a highly efficient representation of sparse matrices that stores only the non-zero values and their corresponding indices. This format is commonly used for storage and manipulation of sparse matrices in libraries like scikit-learn. L2 normalization, a process used to scale data by dividing each row by its L2 norm. This ensures that all rows have a unit norm and helps prevent features with larger magnitudes from dominating the model. For example, in a dataset with features like age and income, income might have a much larger range than age. L2 normalization helps to balance their influence. In-place operations that modify the original data structure directly instead of creating a new one. This can be very efficient in terms of memory usage. For example, in data cleaning, you might need to replace missing values with the mean of a column. An in-place operation would directly modify the original data, saving memory compared to creating a new copy. Sklearn, a popular Python library for machine learning, offering a wide range of algorithms and tools for data preprocessing and model building. It provides functions like in-place CS-row normalizer to efficiently handle sparse matrices, making it a valuable tool for working with large and complex datasets. SparseFuncs, a module within Sklearn that provides optimized functions for working with sparse matrices. It includes functions specifically designed for speed and efficiency when dealing with sparse data. Machine learning, a field of computer science that deals with the development of algorithms that allow computers to learn from data and make predictions. L2 normalization, a technique used in in-place CS-row normalizer 2, is a common data preprocessing technique used in machine learning to improve model performance. Feature engineering, the process of selecting, transforming, and creating features from raw data to improve the performance of machine learning models. L2 normalization is a form of feature scaling, a common feature engineering technique. Data preprocessing, the process of cleaning, transforming, and preparing data for use in machine learning models. In-place CS-row normalizer 2 is a data preprocessing technique used to normalize sparse matrices, ensuring they are ready for use in machine learning models. 0, 1, 0, 2, 1, 0, 3, 0, 0, 2, 0, 1. L2 norm of row 1 SQRT02, 1202, 22 SQRT5. Normalized row 10, 1 SQRT5, 0, 2 SQRT5. Which of the following sklearn, utils functions is primarily used for converting data into a format suitable for machine learning models? A. sklearn, utils, checkarray. B. sklearn, utils, shuffle. C. sklearn, utils, checkrandom state. D. sklearn, utils, safe indexing. E. All of the above. Ensures the input data is in a suitable format for machine learning models. It checks for data types, missing values, and dimensionality. Correct. Function explanation. sklearn, utils, checkarray. Ensures the input data is in a suitable format for machine learning models. It checks for data types, missing values, and dimensionality. Randomly shuffles the rows of a dataset, often used to break patterns and improve model generalization. Correct. Function explanation. sklearn, utils, shuffle. Randomly shuffles the rows of a dataset, often used to break patterns and improve model generalization. Converts an input into a random number generator object, ensuring consistent random number generation across different executions. Correct. Function explanation. sklearn, utils, checkrandom state. Converts an input into a random number generator object, ensuring consistent random number generation across different executions. Safely indexes data structures like NumPy arrays while handling cases where indices are not integers, e.g., lists or Boolean arrays. Correct. Function explanation. sklearn, utils, Safe indexing. Safely indexes data structures like NumPy arrays while handling cases where indices are not integers, e.g., lists or Boolean arrays. All of the listed functions play a crucial role in preparing and manipulating data for machine learning models. Correct answer: font color green. E. All of the above. Font E. All of the above. Data preprocessing. Transforming raw data into a format suitable for machine learning models. Data preprocessing. Transforming raw data into a format suitable for machine learning models. Data validation. Ensuring data meets the requirements of machine learning algorithms. Data validation. Ensuring data meets the requirements of machine learning algorithms. Data transformation. Applying various techniques, e.g., scaling, normalization, encoding to modify data features. Data transformation. Applying various techniques, e.g., scaling, normalization, encoding to modify data features. Random number generation. Generating random numbers for tasks like model initialization and data shuffling. Random number generation. Generating random numbers for tasks like model initialization and data shuffling. sklearn, utils, checkarray. Ensures the input data is in a suitable format for machine learning models. It checks for data types, missing values, and dimensionality, ensuring consistent data format before training a linear regression model. Function explanation. sklearn, utils, checkarray. Ensures the input data is in a suitable format for machine learning models. It checks for data types, missing values, and dimensionality. Use case. Ensuring consistent data format before training a linear regression model. sklearn, utils, shuffle. Randomly shuffles the rows of a dataset. Often used to break patterns and improve model generalization. Shuffling training data before splitting it into training and validation sets. Function explanation. sklearn, utils, shuffle. Randomly shuffles the rows of a dataset. Often used to break patterns and improve model generalization. Use case. Shuffling training data before splitting it into training and validation sets. sklearn, utils, check random state. Converts an input into a random number generator object. Ensuring consistent random number generation across different executions. Initializing the random state for a k-means clustering algorithm. Function explanation. sklearn, utils, check random state. Converts an input into a random number generator object. Ensuring consistent random number generation across different executions. Use case. Initializing the random state for a k-means clustering algorithm. sklearn, utils, safe indexing. Safely indexes data structures like NumPy arrays while handling cases where indices are not integers, e.g., lists or Boolean arrays. Selecting specific rows from a dataset based on conditions or labels. Function explanation. sklearn, utils, safe indexing. Safely indexes data structures like NumPy arrays while handling cases where indices are not integers, e.g., lists or Boolean arrays. Use case. Selecting specific rows from a dataset based on conditions or labels. Which of the following accurately describes the functionality of a sklearn, utils, graph single source shortest path length function? It is used to a. Calculate the shortest path between two nodes in a graph. b. Find the shortest path from a source node to all other nodes in a graph. c. Determine the number of shortest paths between two nodes in a graph. d. All of the above. a. Calculate the shortest path between two nodes in a graph. This is correct. The function can indeed find the shortest path between any two nodes you specify. For example, If you have a graph representing a road network, you could use this function to find the shortest route between your home and work. True. B. Find the shortest path from a source node to all other nodes in a graph. This is also correct. It can calculate the shortest paths from a starting node to all the other nodes it can reach. Imagine you are planning a delivery route, and you want to find the shortest paths from your warehouse to all the delivery locations. This function could help. True. C. Determine the number of shortest paths between two nodes in a graph. This is correct too. The function can count how many different shortest paths exist between a pair of nodes. If you are analyzing social networks, this could help you understand how many different ways people can connect with each other. True. D. All of the above. Because A, B, and C are all accurate descriptions of the function's capabilities, the correct answer is D. All of the above. True. D. All of the above. Graph representation. A graph is a data structure comprising nodes, vertices, and edges connecting them. Shortest path problem. The goal is to find the shortest path between two nodes in a graph, considering the distance or weight associated with each edge. Algorithms. Various algorithms like Dijkstra's algorithm and Bellman-Ford algorithm are commonly employed to solve the shortest path problem. Graphs are powerful data structures that can represent relationships between objects. The shortest path problem is a classic problem in graph theory with many real-world applications. Algorithms like Dijkstra's and Bellman-Ford provide efficient solutions for finding these shortest paths. Navigation systems. Finding the optimal route between two locations. Network routing. Determining the shortest path for data packets to travel through a network. Social networks. Analyzing connections and identifying influential nodes in a social network. Recommender systems. Suggesting relevant products or content based on user preferences in connections. Shortest path algorithms have diverse applications. In navigation systems, they help find the best routes. In networking, they are crucial for routing data efficiently. They are also used in social network analysis to identify important nodes and understand relationships, and in recommender systems to suggest content based on connections between users and items. What does the sklearn, utils, random, sample without replacement function do? It generates random samples with replacement from a given population. It generates random samples without replacement from a given population. It shuffles the elements of a given array. All of the above. It generates random samples with replacement from a given population. False. This is incorrect. The sample without replacement function specifically focuses on generating samples without replacement, meaning an element is chosen only once. It generates random samples without replacement from a given population. True. This is the correct answer. The sample without replacement function generates random samples from a given population without replacement. This means that an element can only be chosen once in the sample. It shuffles the elements of a given array. False. This is incorrect. While shuffling involves random order, it doesn't focus on selecting specific elements like sample without replacement does. All of the above. False. This is incorrect. As explained earlier, options A and C are not correct, making the entire statement incorrect. B. Python. From sklearn, utils, random import sample without replacement. Population 1, 2, 3, 4, 5. Sample size 3. Sample without replacement population. Sample size. Print sample. This code snippet demonstrates how to use the sample without replacement function. It takes a population, a list of elements, and the desired sample size as input. The function generates a random sample without replacement, ensuring that each element is selected only once. Data sampling, creating a representative subset of data without replacement for training and testing. Machine learning models. In machine learning, we often need to split our data into training and testing sets. Using sample without replacement helps create balanced subsets for training and testing to avoid bias introduced by selecting the same data multiple times. Random selection, picking a random subset of items from a list without allowing duplicates. Imagine you have a list of tasks and you want to randomly select a few to work on without repeating any. Sample without replacement allows you to do this efficiently. Lottery simulation, simulating a lottery draw where each number can be picked only once. In a lottery, each winning number is drawn only once. Sample without replacement allows you to simulate this process accurately by generating random numbers without replacement. Random sampling. Random sampling is the process of selecting a subset of elements from a population. There are various techniques for random sampling, including sampling with and without replacement. Sampling with replacement. In sampling with replacement, an element can be chosen multiple times. This means after selecting an element, it's put back into the population, making it eligible for selection again. Sampling without replacement. In sampling without replacement, an element can be chosen only once. This means after selecting an element, it's removed from the population, making it unavailable for future selection. Population. The population refers to the complete set of elements from which we want to draw a sample. It could be a list of customers, a set of products, or any other group of items. Sample. A sample is a subset of elements selected from the population. It's a smaller representation of the entire population used for various purposes like analysis or prediction. Sklearn. Sklearn scikit-learn is a popular Python library for machine learning and data science. It provides a wide range of tools and algorithms for various tasks, including data preprocessing, model building, and evaluation. You have a list of 10 unique items. You want to randomly select 5 items from this list without any duplicates. Which function from sklearn, utils, random would you use? A. Random sample. B. Random choice. C. Random randint. D. Random sample without replacement. A. Random sample. False. While random sample can generate a random sample, it doesn't guarantee the items are unique when replaced. False. It's possible to get duplicates in the sample. B. Random choice. False. Random choice is designed to select a single random item from a sequence. It doesn't allow you to select multiple items without replacement. C. Random randint. False. Random randint generates a random integer within a specified range. It's not directly applicable to selecting items from a sequence. D. Random sample without replacement. True. This function is designed for this specific scenario. It ensures that each item is selected only once, guaranteeing uniqueness in the selected sample. D. Random sample without replacement. Random sample without replacement. This function is used to sample a specified number of items from a sequence without replacement, ensuring that each item is selected only once. Randomly selecting a subset of data points for training a machine learning model. Creating a random sample of customers for a marketing campaign. Performing random experiments with a limited set of data points. Simulating random events where repetition is not allowed. Generating random test cases for software testing. sklearn, utils, random, sample without replacement population, n samples, replace false, random state none. Imagine you have a list of 10 students population 10 and want to randomly select 3 n samples 3 for a presentation, ensuring no student is chosen twice. Random sample without replacement population 10. N samples 3 would return a list of 3 unique student names from the original list of 10. Which of the following functions from sklearn, utils, array_cs can be used to efficiently concatenate multiple arrays along a specific axis? Handling potential mismatches in shape. A. Font style font size 16px columnar 1 die font. B. Font style font size 16px check array. Ensure 2D false font. C. Font style font size 16px astride array, shape none, strides non a font. D. Font style font size 16px concatenate arrays, axis 0 font. D. Font style font size 16px concatenate arrays, axis 0 font. The concatenate function from sklearn, utils, array_cs is designed for efficiently joining multiple arrays along the specified axis. It intelligently handles potential shape discrepancies, ensuring seamless integration. The concatenate function is specifically designed for concatenating multiple arrays along a specified axis, taking care of potential shape differences. This makes it the best choice for efficiently combining arrays while ensuring compatibility. 1. Combining feature matrices from different data sources. Br2. Concatenating outputs from multiple models for ensemble learning. Combining feature matrices from different data sources. Imagine you have two datasets, one with user demographics and another with their purchase history. You want to combine these datasets to create a comprehensive feature matrix for a machine learning model. The concatenate function allows you to do this efficiently, even if the datasets have different numbers of columns features. Python. From sklearn, utils, array_cs import concatenate. Sample data. Demographics 25. Male. 30. Female. 40. Male. Purchase history 100. 200. 50. 150. 250. 300. Concatenate along axis 1 columns. Combined data concatenate demographics. Purchase history. Axis 1. Print combined data. Concatenating outputs from multiple models for ensemble learning. You have multiple machine learning models predicting the same target variable. For better prediction accuracy, you want to combine the outputs of these models using an ensemble method. The concatenate function helps you merge the individual predictions into a single array for further processing. Python. From sklearn, utils, array_cs import concatenate. Sample data. Model 1 predictions 0.2, 0.8, 0.1. Model 2 predictions 0.7, 0.3, 0.9. Concatenate predictions into a single array. Combined predictions concatenate Model 1 predictions. Model 2 predictions. Axis 0. Print combined predictions. 1. Array manipulation. 2. NumPy arrays. 3. Sklearn utilities. 4. Shape compatibility. 5. Data preprocessing. 6. Concatenation. Array manipulation. The ability to modify and combine arrays based on specific operations and rules. NumPy arrays. NumPy arrays are fundamental data structures in Python for numerical computations. They are essential for array manipulation and operations in machine learning. Sklearn utilities. Sklearn provides a range of utility functions, including array-fun CS, to facilitate data handling and preprocessing tasks in machine learning. Shape compatibility, ensuring that arrays have compatible dimensions for operations like concatenation or matrix. Multiplication, data preprocessing, the process of preparing raw data for use in machine learning models, including tasks like cleaning, transformation, and feature engineering. Concatenation, the process of combining multiple arrays into a single array along a specific axis. Font style font size 16px columnar 1 die font. The columnar 1D function is used to ensure that an input is either a 1D array or a 2D column vector. It does not perform concatenation. This function is not designed for concatenation. It's meant for ensuring a specific array format 1D or column vector, which isn't the requirement for the question. Font style font size 16px checkarray array, ensure 2D false font. The checkarray function checks if an input array meets certain requirements, such as being at least 2D or ensuring a specific data type. It doesn't concatenate arrays. This function is primarily for data validation and does not involve combining multiple arrays, making it unsuitable for the question. Font style font size 16px astrid array, shape none, strides none a font. The astrided function provides a view of an array with different strides and shape, essentially creating a virtual view without copying the data. While it can be used to manipulate arrays, it's not designed specifically for concatenation. While astrided enables flexible array reshaping, it's not the primary function for merging multiple arrays. Its purpose is to create virtual views of existing data, which is different from concatenation. What is the primary function of sklearn, utils, array-fun CS, minpos? A. Finds the minimum value in a given array. B. Finds the index of the minimum value in a given array. C. Sorts a given array in ascending order. D. All of the above. 1. Finding the minimum value. This is its core functionality, directly returning the smallest element in the input array. This choice is correct. The function minpos essentially finds the minimum value within an array. For example, if we have an array 3, 1, 4, 2, it would return 1 as the minimum value. The function doesn't explicitly sort the array but identifies the smallest value within it. True. 2. Finding the index of the minimum value along with returning the minimum value. It also provides the index of that value within the array. This choice is also correct. The function minpos doesn't just give you the minimum value, it also tells you the position index of that value in the array. Continuing with the array 3, 1, 4, 2, the function would also indicate that the minimum value 1 is located at index 1 in the array. True. 3. Sorting the array. While not its explicit purpose, the function indirectly contributes to sorting by identifying the minimum element, which forms a key part of sorting algorithms. This choice is correct, but it's important to understand the nuance. While minpos doesn't explicitly sort an array, it indirectly helps sorting algorithms. Finding the minimum element is a crucial step in many sorting techniques. For example, selection sort relies on repeatedly identifying and placing the minimum element in its correct position to sort the array. True. The correct answer is D, all of the above. Given that all the previous options are correct, this is the correct answer. The minpos function is capable of finding the minimum value, its index, and indirectly contributes to the sorting process by providing the minimum element. True. D. All of the above. Arrays are fundamental data structures in programming. They allow us to store collections of elements, often of the same data type, In this case, the minpos function operates on an array of values. Finding the minimum value within a dataset is a common task in data analysis and optimization. It helps us identify the smallest element within a set of numbers, which can be useful for various applications. An index is a numerical value that represents the position of an element within an array or data structure. Knowing the index of the minimum value allows us to easily locate and work with that element. Sorting algorithms arrange elements in a specific order, usually in ascending or descending order. The minpos function, by identifying the minimum element, plays a crucial role in some sorting algorithms. Data analysis involves examining data to extract insights, patterns, and relationships. Understanding minimum values and their positions can be valuable in data analysis tasks. Machine learning algorithms often rely on data analysis and optimization techniques. The minpos function can be helpful in tasks like feature selection or model parameter tuning within machine learning. Optimization aims to find the best possible solution within a given set of constraints. Identifying the minimum value is a common optimization objective, especially in finding the most efficient solution for a problem. Algorithms are step-by-step procedures that solve a specific problem. Sorting algorithms, for instance, use strategies to arrange data in a particular order. The minpos function aids in the implementation of such algorithms. 3, 1, 4, 2. Let's consider an array 3, 1, 4, 2. Applying the minpos function to this array would return the minimum value 1 and its index 1. It would also indirectly contribute to sorting algorithms by identifying the smallest value for each step of sorting, which is crucial for algorithms like selection sort. Which of the following options best describes the purpose of metadata routing in sklearn? To store and retrieve metadata associated with data transformations. To manage the flow of data through a sklearn pipeline. To optimize the performance of sklearn algorithms. All of the above. True. Metadata routing in sklearn is designed to track and propagate metadata about data transformations. This metadata can include feature names, data types, missing value handling strategies, and other relevant information. It enables efficient storage and retrieval of this information, aiding in data understanding and analysis. True. Metadata routing plays a crucial role in pipeline management. It ensures that metadata is correctly propagated across different stages of the pipeline, enabling seamless data flow and consistent data representation throughout the machine learning workflow. True. While not the primary function, metadata routing indirectly contributes to performance optimization. By maintaining accurate metadata about data transformations, it helps ensure that algorithms operate with the correct data representations, potentially leading to improved performance and reduced errors. True. The correct answer is D. All of the above. Metadata routing in sklearn effectively achieves all the mentioned purposes. It efficiently stores and retrieves metadata associated with data transformations, manages data flow through pipelines, and indirectly contributes to algorithm optimization. D. All of the above. Information associated with data, such as feature names, data types, missing values, and other relevant details. Consider a dataset with features like age, income, and city. Metadata associated with this dataset might include feature names, age, income, city, data types, integer for age, float for income, string for city, missing values, indication of missing values in the income column. Operations applied to data, such as scaling, encoding, or feature engineering. Scaling, standardizing the age feature to have a mean of 0 and a standard deviation of 1. Encoding, converting categorical features like city into numerical representations. A sequence of data transformations and estimator steps, used to streamline the machine learning workflow. A pipeline for predicting customer churn might include data transformation, scaling features, handling missing values, estimator, logistic regression model to predict churn. A machine learning model that learns from data to make predictions or perform other tasks. Logistic regression, random forest, support vector machines are examples of estimators. Facilitating the use of custom transformers with pre-existing scikit-learn pipelines. If you develop a custom data transformation, metadata routing allows you to seamlessly integrate it into a pre-built scikit-learn pipeline. The pipeline will automatically manage the metadata associated with your custom transformation, ensuring proper data flow and consistency.